S 1, 2, 3, 4, 5, 6, 7, 8. Yes, walking.
All right. Tiny.
Good morning.
Ilya.
Yes,
Nice to see you. I'm Jeff.
yeah, nice to meet you. I'm just running around checking the rooms, seeing if everything's fine.
Well, FUNARCH doesn't technically start till 11, but I was like, I want to get here early, make sure everything works.
That's okay. Yeah, I just saw the AC guy, so that should be on
Okay.
in a few minutes.
Yeah.
Because we booked it, it's just they screwed up as well.
It's
happens. Always something happens. So
Oh, I mean, if it wouldn't be a conference if everything went to plan, you
yeah,
know?
yeah. Like, even when you think you're taking care of everything. Anyways, I'll see you around.
Okay, yeah, good luck. Hello,
Check the earphone.
hi, go ahead.
Hello, you are the first speaker.
No, I'm running the workshop.
Oh, yeah, I mean, you are the first to present everything.
No,
No.
I'm running the workshop.
Oh, I mean the workshop, oh, okay.
Oh, you're the,
I'm in charge of the security, any
Yeah.
issue can just look for me. I just trying to see if you are using laptop or desktop.
Oh, I plan on using the desktop,
Hmm.
but I wanted to make sure I connect to my laptop just in case. Is Dropbox on here?
Hey, you can.
Yes, please do.
Laptop, are you connected?
Oh, I am, I can disconnect.
Once you connect, you should just,
Oh, it's an issue with my computer.
I think there's still.
No, this is on my side, I know it is, because I have a custom manager set up. Yeah,
Yes.
so it's okay.
Okay.
Yeah.
Then why not you just use Zoom? Then we can let you share screen.
Oh,
Will that be okay?
well, I don't intend on using my laptop, it's just a backup.
Okay.
Redundancy.
Oh,
So I
okay.
intend on using this desktop.
And
Yeah.
so you got all the slide with, have you uploaded your slide into the?
Yes. So yes, I would like to be able to see.
Yeah, let me see. Okay,
Ah,
all the slides here, which one is yours?
Ah.
Probably just need to find it.
No,
What you
it's
did.
this one and this.
Oh, okay, okay.
So this is perfect though.
You want to open it and check or something?
Yeah, I actually am gonna open all of these to see.
Okay, okay.
To make sure they work, so that way because I have one speaker live, one giving a live remote and one recorded.
Okay, will there be more slides?
I don't think so, no.
Okay, can. Good
Yeah.
idea.
Yeah, we didn't have many submissions this year, sadly, so.
Because if there's more slide, means I have to re-download again, then
I
I
understand.
will come in a bit later.
If that happens, I'll let you know,
Yeah,
but
okay.
none are planned,
Okay, okay, good.
so,
Thanks.
okay, thank you.
Yeah, no problem.
Good morning. Name's Jack. How do you do? Can you hear me?
Yeah, no, it's the only one we want this.
Oh, great, thank you. Yeah, I'm running the workshop. Oh, perfect. So I am just making sure. This is I'll show you. If everything goes well, you will really have to do almost. Yeah, hopefully that's okay. Our program is very small, because we only got 4 submissions this year. So we don't actually start till 11, and then we end at 4. And these lightning talks, one lightning talk is by Tom Ellis, that's this one, and then I'm giving. So it should be okay, yes. What are your responsibilities as a student volunteer?
I'll just like make sure that everything runs well and so count like the number of participants.
Okay.
And I'll manage any Q&A areas.
There will be Q&A. I would like to put a sign out on the door
Oh,
so that people can find their way here. But I was thinking of just like writing on the back of some paper. Do you know what paper is?
I can try to get.
I can also do that. I don't have much to do in this room now. So yeah. I think, is there anything else? I don't think so. This is a pretty small endeavor, so hopefully fairly easy. Yeah. I think the big things are just, I need to connect to Zoom and oops. I don't think I even have it installed.
Do you have the Zoom links?
Yes,
Okay.
but there you go. So, yeah, but I intend to be on Zoom and the Discord while most people are talking. Yeah, and I guess that's, you will also be there with field questions. Nice to meet you.
I'm going to Pinterest.
Okay.
Oh, wait, it's supposed to be a volunteer here.
She was here.
Oh, she was, okay, any issues getting set up?
Not yet, I'm trying to figure out.
Okay.
But
Sorry,
this,
I'm kind of new to this.
hey, me too. This workshop doesn't start till 11, so there's still lots of time.
Oh, I see, okay.
Yeah.
Well, then that's, okay, sorry,
Yep.
we'll go check on another room then.
Okay. Where is my copy? I want.
We do.
This is muted, it's another microphone, it's gotta be this one. I'm testing. Testing. I'm very low. How do I sound?
Hello, everyone, welcome to Playing Day.
But you cannot hear me. Testing. Okay, it does work. Okay, so then why can't I hear me through me?
Functional UI Paradigms by Mike Schwerber and myself, Markus Schläger. Our paper consists of
Okay, now I can.
two parts.
Hi, are you here for the talk?
Yes.
Okay, sure.
Cool stuff, you know. I guess. Yes, yes. That's how I can. As soon as that's. So it's great. Oh, I was like, you uploaded.
I uploaded the slide, yes.
Yes, but it's a PDF. Did you intend for it to be a PDF?
Oh, this,
It's up to you. It's okay.
I can, so it's basically on Mac, like Mac OS Keynote file, or so I just assumed, didn't it say it should be a PDF?
Oh, I don't know. I assumed it should be a PowerPoint.
Yeah, I don't know, I didn't, if I convert it to PowerPoint, then the stuff always gets
Okay.
lost, but
Yes.
you can put that in presentation mode, so I can,
Oh, you can. How do you?
I would assume that.
But this is browser.
Otherwise, I also got it on my laptop, if you have HDMI.
There's an.
Then let's, I just uploaded it just to be safe, because it,
Yes, I just noticed there was a PDF.
yeah,
Yeah.
yeah, no, but because I think you can't really upload Keynote like from the.
Yeah, I wouldn't have, because this would be running. But I was trying to find you in the, or looking for you in the.
Yeah, I was talking, I just realized how late it already.
It's okay. We don't have very many talks.
Yeah. And then. Nine. I mean, it's usually should be fine, but
I think it'll auto find it when I was in the phone.
because in the instructions, it seems like they really preferred.
Yes. Yes, it does seem that way, but it's always somewhere. And then the next thing we need to do, so then we'll.
Do you have a clicker
I
or
really don't.
then if you
I can
works
ask
here,
one of the
right?
organizers. I can ask one of the organizers. But
Yeah, otherwise, I mean, usually if. Because it's probably an euro, and then the remote should work. Should be able to use this as a remote. Let me. Yeah. Right. So. That's pretty.
And then you need to
And
join
then-
the Zoom and president as well.
Oh, do I have to?
Yeah, so the Zoom call shows this. So what we'll do is, because we want this microphone to be alive,
Yeah.
so this Zoom will just stop sharing. And then I can send you the Zoom details if you don't.
Okay, yeah. I think I have it in some email.
Yeah,
Let me
let's
check.
Yeah, I sent this email.
So, it's the Zoom link, this was the Zoom link.
No, this is earlier. I sent this out like a few days ago. This from CRP.
Okay, I was searching
Yeah, that was
for.
an easy tweet.
Yeah. No, that's the same. No, no, the Zoom one didn't really, I'm pretty sure I got it. I think I did see something about Zoom. Some. Maybe that's email,
Oh.
something, but
Well, I can
the
send you,
confusion is what.
I can send it to
Be
you.
on my end, it's okay.
I can send it to you.
Yeah.
What's a good email?
G.K.Keller. You
you.
Ah.
See. Yeah, you
Yeah, big, exactly. Oh, yeah, Zoom link for Sunday, actually it was, that's it, right?
Yes.
It was from 10.
Yeah, there was confusion about this right there. Yeah, Michael Sperber also emailed me about this and I was like, hey, organizer supposed to be there. I couldn't be in.
Does it need to find
It doesn't.
it out? Actually.
And then sharing. That's. Oh, you have to grant it access to share screen. Oh. Sure. Okay. That's good. Okay, just wonderful. And then you form it. So I would just say, welcome to FUNARCH and introduce you and the rest of yours. We have an ample amount of time.
Okay, yeah.
So if you need more.
35 control.
Yeah. I mean, it's like when you have a birthday. And then when you see me stand up, I'll do this for 10. Just want you to. I wanted science, but they couldn't find pictures, so.
Does it make sense to go into a different view here, because?
Oh, I think this is your Zoom. Oh,
Then maybe I can get the Zoom
Or
into
mine.
full screen.
oh, I think you should just show keynote. Or mine, is this?
No, I think that's not my,
Yes.
basically, I think that should be.
This is still playing this computer.
I mean, I guess it's okay.
Well, I think. Okay, this one we do. Cause this is. Oh, yeah, no,
Yeah, I unplugged the HDMI, just,
there we go.
Well,
Perfect. Okay. How many? I guess we can give people 2 more minutes.
yeah, it's still.
Everyone does this. They always try to. It's this door. It's this door.
Thank you.
Yeah, you're welcome. You should have made it so you can come into that.
No, because this is closer to the fire exit, maybe.
Oh, yeah, that's.
Yeah.
Okay, it is time. Let's begin. Hello, everyone. Welcome to FUNARCH 2025. My name is Jeff. I will be chairing this little endeavor. I don't think anyone else is on Zoom, so I'll just introduce our first presenter. Gabrielle Keller is going to talk to us about layered certified compiler architecture. She comes from Utrecht, I think, and the floor is yours.
Thank you, Jeffrey. Good morning, everyone. Yeah, I'm going to, my talk is about the layered certified compiler architecture project. And the project is joint work, or if I say joint work, I said the main person who's actually doing the work. So if I say it is called we implemented or something, that actually means Jakau, who's the PhD student on the project. He did most of the implementation work, and Joris Ralph, he's a master student who worked with Jakau, and Manuel Wout and I, the supervisors for Jakau. What you want to talk about verified compilation. So many people are into verification, so I don't really have to explain much, but in general, I mean, if we want to prove anything about an application, so all of our proofs kind of depend on the fact that the underlying infrastructure, such as compiler, operating system, and then of course the hardware is correct. Now, I'm not going into these two topics, but the kind of verifying or making sure that the compiler is correct is what we're looking at, because the applications we're dealing with are kind of fairly sensitive, and we want to really make sure that it's correct. Before I start going to technical details, just a few things about the context of the project in which this kind of whole architecture came up. So I've been looking at the Flink compiler, and I don't know if you ever heard of Flint. Otherwise, it might be more familiar under the old name Plutus. Plutus or Flink now is basically a contract language for the Cardano blockchain, and it's a kind of fairly large subset of the Haskell language, and we're using also it's kind of the GH3 is part of. And of course, kind of smart contracts control a large number of financial assets, and it's kind of important that those contracts do what we expect them to do. It's not just a theoretical problem, so there have been problems with smart contracts, which were basically caused by bugs in the compiler of those smart contracts. And what makes it even worse in the smart contract context for blockchain is, of course, that basically the compiled code is on the blockchain, and if you have buggy code on the blockchain, it's even harder to change that because it is on the blockchain. So we really want to get this right. Now, one problem, of course, which everyone who's kind of done anything with verification, it's extremely tedious, it's extremely time consuming, and it is very, very expensive. So if we look at just two of the kind of more famous projects of verified infrastructure, the Concert compiler is a very good successful example of that. And it's a huge project, like it's a multi-year effort of a very large team. Another project some people in the audience know about is the SL4, kind of a microkernel of an operating system. And that's roughly kind of, it's not that big, even it's 10,000 lines of code, but it took about 20 plus years. So if you compare our project to these projects, just in size, it's basically kind of a one full-time person who is on the project, then Liyako, then a few percent of my time, Manuel and Wouter's time, and then various master students. What makes it also more complicated is that the kind of language is still in flux. Like with the language they wanted to compile was pretty clear and fixed in the beginning, and the compiler itself is still kind of under development. So, is there any point in trying to do something useful given this size comparison at all? And I try to convince you today that yes, there is, even with a very, very small budget. And if you look at kind of verified compilation, the kind of route Comstat, for example, took is kind of verifying the compiler. So the idea is that we write a proof to show that for all possible source programs, the compiler will produce correct code. And of course, compilers are complex pieces of software, so proofs are an order of magnitude bigger than the actual software. So it's a huge proof. Then if the compiler changes, the proof needs to change. And then what we do need is basically full access to the compiler code and control over the compiler code to prove that the code is correct. Another approach is basically that we're going to try and write a program that for a given program that is compiled generates proof that the compilation the compiler did for that program is correct. And then, I mean, the size of the proof obviously also scales with the size of the program you're computing, but usually most programs you write are smaller than a full compiler. And in particular, in the context of smart contracts, they're fairly small programs. So the proof is usually much, much smaller. And then the proof generator does not necessarily have to change if something in the compiler changes. Like, it's obviously not independent of it, but if you don't hard code basically the actual compilation into the proof, it's a bit more independent from this. And also, we don't need full access to the compiler necessarily. And I want to explain that in a moment. So if you look at the kind of compilation pipeline, then if we have the idea, basically we take the source and the target, and then we try to write the certifiers that takes these two things, these two objects, and tries to provide a proof of semantic relation between the source and the target. Now, if I don't know anything about the compiler, there might be a huge gap between what the source looks like and what the target. So if I don't know anything there, it's very unrealistic that I can generate a proof why they are the same, or they were a semantic refinement or something, but why they are related. But if you have a multi-pass compiler where each pass does fairly little, then it kind of looks something like this. So first compile it to some intermediate representation, which is still fairly close to the source, and then each pass kind of changes this a little bit. And I might have a number of different languages in here, typically a lot fewer languages than I have passes. And then if I have enough access to the compiler to dump the intermediate representation, then, well, the certifier can take these and try to generate proofs for each step. and then chain them together and hopefully be able to plug them together to get a correctness certificate for that. And so that's why I said basically it's not, we don't need full access to the compiler, but we need access to the code so that we can at least dump the intermediate data structures. Okay, so if you break the problem down to first trying to prove the correctness of a single pass, how can we do that? And that's kind of the core of this paper or our approach. We came up with this kind of layered architecture, that consists of different components. So the first one, which we basically already saw, is we need kind of an interface layer, more or less the parser, a pretty printer in the compiler, and then a parser, a proof assistant to bridge the gap between the compiler and the certifier. Secondly, for each pass, we have to specify what the pass is supposed to do. Then, given the specification, we somehow need to have a kind of generator that gives us a decision procedure that for two ASTs shows us that they are in the relation defined by the specification of that here. And then finally, we also have to show that the specification actually preserves that if it's kind of behaves according to the specification, that the specification preserves the semantic relationship we are interested in. Now, what I want to do is kind of briefly go over the kind of more like abstract things of what these layers do, and then go through an example of a concrete path how we can do that. So the interface layer, as I said, is basically just a pretty printer and a parser. Pretty straightforward. One issue, of course, is if we talk about proofs, then the pretty printer we should verify something that it is the right thing. Yeah. Now, since our project is fairly small, so we opted to kind of just use take that as part of the trusted base. So we did not verify anything about the pretty printer in the parser. Yeah. So, but it's not, there's no reason why this couldn't be done. We just didn't do that. Then the specification layer, here what we want to do is basically define a relation between source terms and target terms that describe what the pass does. And I said in the beginning, we kind of want to stay, or it's good if it can stay as far away from the actual implementation as possible. So the more abstract the specification is, the more wiggle room it leaves, the more likely it is that we don't have to change that if the implementation changes. So it should not be kind of close to the implementation. And then for the automation layer, so we want to basically implement a decision procedure which takes two ASTs, source and target AST, and kind of checks whether they are in that relationship. And then, sure.
Is the languages, do they include kind of metadata related to analyses? Like,
yeah.
Okay.
Yeah, they can. So if I don't come back voluntarily to this in the talk, then remind me, then I can give you some more. Yeah.
Sorry.
Yeah, no. It's a good question. It's important. And then for the verification layer, what we have to provide here is kind of a proof that if two terms are in this relation we defined previously, then this implies some semantic relation. And now, kind of some information about the compiler, some information about the compiler we applying this to. So the point/Bluetooth compiler, as I said, it's point is a subset of Haskell. So, and it's compiled by GHC to GHC core. And then to the point intermediate language, which is just basically kind of a superset of system atomy omega with letrec and algebraic data types. And most of the passes we're looking at basically happening here. And then it is further constrained to PLC, which is a subset. It's basically system omega. So we don't have to, we can reuse, because these languages are fairly similar, we can reuse most of the things which are which we have to do per intermediate language, we can reuse here. And then finally, it's translated to UPLC and typed PLC. So in some sense, this approach is particularly kind of useful in this compiler setup because it operates a lot on intermediate languages which work on similar abstraction level. But I will also talk in give example in the code how we could adapt the architecture if this isn't the case, because it's not true for everyone. And then the certifier is implemented mostly in Rock. Again, name change here from the former clock. A part of it from the pretty printer, which is implemented in Haskell. And then we have some command line tools for convenience, which plug things together, plug proof scripts together, which are implemented in Haskell and is kind of maintained separately from. So yeah, let's have a look at kind of a concrete actual path, compiler path, inlining, just to give you an idea how that looks in reality. We also use a more simple language than Plint, just this kind of lambda calculus with let bindings. In the paper, you will also find kind of the discussion of to compiler passes on the actual Plint language, but it's a bit too complex here for the. So kind of just the lambda calculus, but also like this. And then how does inlining work? All know, but if you have something like this where x is bound to 3, then we replace some occurrences of x, maybe all, maybe none, but we replace some of occurrences of x with the value it's bound to. So first step, the specification layer. So we write down this relation between kind of given a context or an environment, then source term S is related by inlining to T, and B context is basically just an ordered list of variables and variable bindings. So it can be the empty thing, variable bound to a value if it was introduced via a let binding, or a variable which is not bound, which is bound but not bound to anything if it was introduced via a lambda abstraction. And then, because it's a very simple pass, the inference rules in this case also look very simple. So x is related to t prime if lookup of x gives me a typed term t, and t can in the same context be inlined to t prime. Another rule.
Excuse me, Gabrielle.
Yeah.
Can you make sure we're recording? I think we didn't hit the recording button.
Oh, there was a warning sign that it was recorded, where is the recording?
There's the pause button up there, so it's probably recorded.
Okay,
Yeah, no, it says,
apologies.
I think, and I did get a little, alert thing that
Perfect.
the talk is
I
recorded.
didn't verify.
I hope.
We can edit this out.
So where was, yeah, and then a variable can also kind of be aligned just to itself, no matter what. And yeah, then if I have a leg binding, then then this is related if the right-hand side of the binding is in line to S prime and T is in line to T prime. Application kind of the same. In line of the lambda expression is kind of here. You can see we put X bound to nothing in the environment. The only kind of interesting thing about this is that the first two rules overlap. Because this rule is always applicable if this rule is, not the other way around, but I can basically just choose to use identity as an inline path and it would match this specification. I won't give too much code, but just kind of rewriting these inference rules into code looks like this. So what we actually do, we go the other way around. Yakov implemented a simple tool that, given such an inductive definition of inference rules, preprints the other rules in LaTeX, so that if you have the specification, it's a lot easier to read. It's for most people, to the LaTeX inference rules than code. But this is kind of straightforward. So next thing is the automation layer. So given this kind of specification, we write a procedure that given an environment and two expressions kind of traverses the expressions to check whether they have this. That's straightforward. What's less straightforward, and to show that the implementation, so we have this decision procedure. Now we have to show that the decision procedure implements the specification. So show that basically if the decision procedure returns true, if and only if, then inlining the kind of inference rules. That's still fairly straightforward because it doesn't talk about semantics at all. It really just shows me that they have this connection. And if we have a proof for this lemma, then we can, so we have to basically, for every pass, we have to prove such a lemma, and then the proof we can generate easily. And then up until now, we've only shown that the translation basically matched the specification. Now we have to show that the specification actually preserves or refines the semantic or whatever kind of relation we want to show. So there are many ways to do this, and this really depends on the source and target language. It's much easier if they are the same, obviously, because then we only have to define the semantics of one of the languages, and we can basically say that they can be equivalent. If they have a very different abstraction level, then we want to specify some kind of refinement relation, so on. But that's really where the hard work is. In our case, in our example, is relatively simple. We can kind of just define a big set of semantics, and restrict those as for the sake of example to proof terms of the type set to set, integer to integer, correct? And then we can define something kind of observable equality when we say, well, for two programs P and Q, we say they are the same. If for any kind of integers n and m, if applied to n gives m in the original term, then the translated term should be same. And then we have this proof obligation to show that if something matches, basically, if they are related to the specification, then this implies observable equality. Okay. Now, if I have all these layers done for one, for all my parsers, then how does it work? So I implement the pretty printer and emit a trace. Now, I said basically the trace is just the AST, or we just print the AST. But sometimes it's also useful, let's say some renaming happens, then the compiler could also give us some more hints. So we here we have like we list all the parsers here. In our case, they don't contain any extra information, but you could kind of put some renaming information or whatever kind. And for more complicated parsers, realistically, we need additional information there. And so we have a term, and then a trace is basically the original source term plus a list of parsers and the term it created. And then if we have the ROC formalization, so all the things I showed you, which we have to do in ROC, the specification, decision procedures, and so on, the certifier basically takes the trace for one concrete program, the formalization, which I have to do once, and then generates a certificate. And what does the kind of certificate look like? I have kind of 3 types of claims because it's a small project. We knew from the beginning that kind of if the success of the project depends on whether we can do all, then we want that success, right? So what we want to have is something that even bits and pieces are already useful. So we have 3 types of claims. One is just according to specification. So we only have the specification and the automation, then we can show that something is according to the specification. If we have all 3, then the claim is basically that a pass is verified, and if some passes are if we're not already there, then it's just unverified. And the claim is basically then for each pass, the function which gives us the claim for each pass, a witness of what we have here, a trace, and then the property. And this is something of the type basically related for each relation, kind of relates term 1 to term 3, term 2 to 3, and so on. And then we try to check whether this is basically. And then finally, basically, the checker takes the certificate, the source, and the target program, and tries to type check it, and then either it's a yes or a no. Now, I said, well, we already wanted to make parts of the development kind of useful in practice. Now, for compiler engineers using rock and things that it's a significant hurdle. So we, and again, the we is Jakob, implemented this formal pedantic mode. And there, in the compiler and how it works, this is kind of an extension of the compiler, which reads in the rock organization via extraction, converts the automation code and everything into Haskell, and then basically checks whether compiler pass already works according to specification, yes or no. So that can be used just by the compiler of the plain compiler developers to see if they changed anything in the past, if it still works according to what they want to do. So what's the state of the current project? And basically, Jakob is just kind of finishing up his thesis, so he's done with the implementation. Now it's just writing time. So he fully implemented and verified non-recursive leg binding translation and then code elimination. And this also basically removes unused code, then cleans up the leg bindings. In the compiler, the code elimination is done in one pass. But in the verifier, it's kind of logically, we split it up in two passes because it makes it more, it makes it simpler. So that is something which for more involved passes is something you probably want to do. He has formalized the peer and PLC semantics fully in Rock and implemented the type system with conversation, short basically static semantic preservation, so that if S is compiled to T for a path, and S has the type tau, then T has the type tau as well. Implemented big steps of substitution semantics, or define the semantic, and then kind of contextual equivalence via step index logical relation. Ahmad basically use this and kind of show the correctness of the translation. And kind of just some numbers. So one of the case studies he implemented is kind of auction contract, which is 268 lines of code. If you look at so you have 362 intermediate ASDs. It's, I think, around 14 distinct passes. So these are not like, it's basically passes like inline or that code elimination run more than once. So the steps, so some of the steps I told you about like are basically per intermediate language, some of the pass, but none are like per distinct pass, but they kind of grow with this number, not with that number. So it takes about 35 seconds to just kind of dump the trace. Then 2 seconds to produce the certificate, and to check the certificate, that's where the work is done, 14 minutes. When you profile where the time is spent is actually kind of the certifier, kind of there you have to pass the rock terms, and the parser is not efficient. So it's mostly release dependent. The parser, you probably want to optimize this, but that was not priority. So there was no kind of time put into that. And also, this is really something you only need to do when you're done and ready and you want to ship the code, then you can kind of, even if for a larger contract this takes overnight, then you do it once. That's not I think, a kind of deal breaker, even if it takes a bit. Then the formal pedantic mode is implemented in the compiler, and it's adds about 1 to 5% in per runtime for the compiler pass. The verification part is by far the most complicated thing, but also the decision procedure for involved passes is also quite some work. And Jakob looked into using the results of the quick chip project to basically automatically design. A lot of this is of the decision procedure is fairly mechanical if you have the inductive definition. So you can kind of automate that as well. And yeah, I think the approach really helps to increase the trust in the compiler. So even if you just verify one pass, you know that this one pass is correct. So kind of in our view, we think given the limited resources we set out with, is actually a fairly pragmatic approach. Many things, we had the plain compiler in mind. And I said, given that a lot happens at a still fairly abstract level, it's particularly well suited. But we think that the general approach is really adaptable to most multi-pass compilers. And the formal pedantic mode is really quite nice because it's easy to use for compiler developers. And that's about it. So thank you very much for coming this morning and for
Okay, we have 8 minutes for questions, and I don't think there's any questions on Discord, so feel free to choose.
You said earlier that you are trying to keep the specification very abstract. And then, but what I also saw is that it seems you're putting the information about the passes into the language that also shows up in the specification. Like which pass you did in some extra information.
yeah, so let's say a pass also renames variables.
My question is, could you make it more abstract by just saying your decision procedure and your verifier would be non-deterministic? And then they just guess this extra information from the point of view of the formalism, but of course they get it via side channel from the compiler.
So the decision procedure itself has to be deterministic, like in the sense that if it gets to ASCs.
Oh no, but I mean specifying how it's written could be non-deterministic. Like sort of gets additional information, guesses the additional information.
Yeah, it could guess. Like you have, it's a trade-off, right? The better, like the more you can guess.
Yeah.
In some sense,
oh no, but when I say guess, I mean you just actually somebody tells you. It just it's not part of the formal thing.
So the decision procedure. Yeah, I think it's a kind of trade-off a little bit, right? Because the decision procedure, the more it has to guess and make up why they are.
Oh no, I'm saying don't actually guess, just get it non-deterministically.
Yeah.
Which it's just a rebranding of how you get your stuff, but it doesn't show up in the official input. You just make like a non-deterministic Turing machine. You have an advice table. And slightly related to this one.
But if it's like this is all type, right? So if it's part of the input, it has to be part of the type. You have to store it somewhere and make it.
Yeah, I don't know about type, like non-deterministic type lambda calculus. Somebody probably looked into that one. And slightly micro question: is the decision procedure total? Does it have to be total, or can it just say for this one I don't know?
It can basically say for some things I don't know. So it's more kind of if you. I think all the things which are implemented are actually total that it can tell you yes or no, but you could think of in a compiler where it's too difficult, then you can't guarantee. And we should that you know, then if it says yes, you know, that's yes, but if it doesn't, then it doesn't produce a certificate and then you don't know anything. You could leave it kind of like, that it's just maybe, basically.
Right. So I'm sorry if this question comes across as a bit mean, but one of my pet peeves about these sorts of solutions is that you're saying, oh, we have a problem with bugs in our compiler. Let's try and solve that by writing a specification and then verifying according to the specification, and then hopefully we have written the specification correctly.
Yeah, but so if we just stick to the specification, basically, the formal pedantic mode just tells you something as the specification. And if you have a bug in the specification, then you gain nothing.
Yeah, exactly. So my point is that, okay, so you have your compiler and your specification and your verification, and then but somehow a bug slipped through.
But if you have the verification, then you know that semantic equivalence. So if you have a bug in the specification, and the specification allows programs which are actually don't preserve.
Yes, that's my point. But
then the then you can't show that then you break basically at the verification level. So if you really have according to the fully verified, then you know that what you know your definition of semantics, of course, like you still
the point I'm getting to is that your specification is only as good as you have an intention, but your intended semantics, and then you have the semantics you specified. The one you've written down.
So if I get the semantics, the specification of the semantics of the language wrong,
exactly. And so
the so are we talking about the specification of a pass? Because if I get the specification of a pass wrong, then the verifier will still pick up on it. If I get the specification, if I get the semantics of my language wrong, then so that's also part of the trust.
And so, but so the reason I raise this is that coming from a sort of practical compiler compiler engineering perspective, if a bug slips through somehow, then all of a sudden I'm left with not only fixing the bug in the compiler, but I would also have to look at there must be a bug or an inadequacy in specification somehow. And so all of a sudden there's more stuff to do in order to fix the bug that's been implemented. And so I'm always worried about these sorts of what is the workload for the sorts of bugs that you would end up having? Because bugs are inevitable in my experience.
Yeah, I mean you can because
and so
can have.
So if I make a constructive suggestion. The two examples you give of two passes that what was it? It was non-recursive let lining and dead code elimination, right? Those are two passes that I would suspect the specification is quite simple, whereas something like peephole pattern optimization would be a difficult one.
I mean, maybe that actually strengthens. So the checker went through for these paths, and then people changed the compiler, and then it broke.
Oh, right.
And it turned out that actually the specification was too narrow. So they kind of they did more in the dead code elimination than was first basically by the people who wrote the specification. So that's kind of according to your, but yes. That's something if and I think it's a trade. So is it good that you now know that your specification actually didn't match the? Yes, it caused extra work because then you have to make the specification more general. Yeah, that's true, but I don't think you can. So what was your suggestion to get?
So one suggestion that I would make is try and implement the solution for a pass where the specification is non-trivial.
Yeah.
So non-trivial. That's not fair to the ones that you have. They're not trivial. But something where specifying semantic correctness from before and after, such as peephole pattern optimization. I don't know that I could write that specification if you asked me to.
And maybe you can't, like,
Yeah.
maybe it's not feasible,
Yeah.
but then you just leave that pass, as kind of, okay, I can't verify that pass. at the
Okay,
moment,
so you just don't
because
try,
I
you
have.
just.
But you
yeah.
still get kind of a certificate that tells you the more simpler passes are kind of correct.
Yeah.
So I think it might, maybe you could then with some more additional information, I don't know, like I won't claim that you can write a specification for all possible passes, but the thing is, what I think it's important from a pragmatic point of view is that the whole thing it doesn't make the whole thing useless.
No, of course, no, I wasn't suggesting that.
But you're right, I mean, it's writing a special, like it's really complicated, everything about verification is just terribly complicated, and as you said, like even if we had everything, then we just exclude some part of bugs, and yeah, it's it's difficult.
With that, I think we're out of time. Let's thank our speakers.
And so you write a specification, just like a write a then you try to write your say, yeah,
Because the fonts are there, but I did you can stop the recording.
But it's also you never know that
yes, in principle,
Marcus, can you hear us?
Yes, I can. Hello, can you hear me?
Yeah, we can hear you. Can you say something?
Yeah, hello, I'm Marcus.
Okay, wonderful. So Marcus isn't going to be giving his presentation by remote. He's given us a pre-recorded presentation. As you can see, he is live for the Q&A. So we will watch his presentation and then do the Q&A. And let me make sure. How do I record on Zoom? Let's make sure we do this correctly.
one person
Record, yes. Record this, record to the cloud. Okay. Wonderful, and that seems like a confirmation to me. Okay, Marcus, I'll play, and then I think in 35 minutes we'll have Q&A.
Yes.
Evolution of Functional UI Paradigms by Mike Schwerber and myself, Markus Schlegel. Our paper consists of two parts. In the first part, which is mostly Mike's work, we discuss the evolution of UI toolkits from the 1990s to the 2010s. And in the second part, we identify an inherent difficulty in working with UIs that is generally not talked about much. We then discuss a new approach to work with this difficulty. The answers of UI toolkits in general, the object-oriented model view controller pattern. MEC is built on the idea of separating concerns of the domain or business logic as the model from concerns of the user interface that is the view. Controller acts as a mediator between these two program parts. In our paper, we identified three main challenges that arise from this pattern. So the update, modularity, and circularity challenges. The update challenge arises because in MEC there's two ways how something appears on the screen. Initially upon UI construction and then incrementally every subsequent update. This may lead to duplicate and therefore strongly coupled logic. For the modularity of challenge, we ask, can we properly separate concerns between model and view? That's the result better for the MEC pattern and also between different parts of the model or different parts of it. And then there's a circularity challenge. So naively implemented changes to the model trigger calls to update the view. But that in turn might spill over into changes to the model, and so we have a circular dependency there. And then as a bonus challenge, we have the event loop, which is a constraint imposed on the frameworks by the platforms, such as the browser runtime, that may lead to the so-called callback hell. Now, there are UI toolkits for functional programming languages that just wrap imperative toolkits like GTK or the web browser's document object model. But right from the start, there were also UI toolkits that tried a more functional approach, like Xene, Fudges, Fruit, and Haggis. However, all of them inherit at least one of the three MVC challenges on the previous slide. And in particular, most inherit the update problem. The Racket Universe Teach Pack specifically addresses the update problem by not making a distinction between initial UI construction and UI update at all, and instead re-rendering the entire UI from scratch on every tick of a logical clock. So here we have the, so to speak, the framework of the Racket Universe Teach Pack. So you don't call these functions, but you have to implement them. You want to write a Racket GUI program, you could say, or a game. So we have an on draw, which takes some state and returns an image, on tick, which moves on the world state. Then you have on key and on mouse, which react to these particular key events or mouse events and update the state and response. And a bit later, there is Elm. So you might know this pattern by the name of the Elm architecture, or sometimes it's referred to as the model update, which is quite similar to what the Racket Teach Pack does. So in the Elm architecture, we have a view function which takes a model, so description of the state, the domain logic, and turns that into HTML. Then you have an update function which takes a message, and these messages come from view and your current model, and it updates the model. And then there's React, which came about at the same time, basically, as the original version of Elm. Facebook released their UI toolkit, which turned out also based on the variation of the model update paradigm. So both Elm and React leave solving this modularity challenge to the developers. Let's go back here. Also here, there's no notion of a UI component. There's just these four functions and these two functions. And how you then decompose them further is that. Sadly, the communities, so the React or Elm communities, they couldn't really come up with satisfying solutions to this modularity problem or modularity challenge. So, for example, even though React, other than Elm, has the notion of UI components built from smaller UI components, the React community adopted the Elm architecture in the form of a library called Redux, for example. And thus, they introduced strong coupling between these components, rendering the idea of individual UI components less useful. And that led to the creation of React. So in 2014, Mike, my co-author, set out to solve the modularity challenge. The closure script library built on top of React called React. And our paper describes in detail how that works. In this talk, I'll not show you React though. Instead, I want to introduce you to another challenge and then show you an update on React called React-C in detail. Few slides. Because even though we were satisfied with React as a solution to the update, modularity, and circularity challenges, and we used that library extensively over many years in our client projects, we felt that there's still something amiss. And one symptom of this feeling was that me personally, I very rarely write automated tests for my UI code. And that's partly due to me being lazy, but I also write few UI tests because I think most UI programs come with vague semantics and are therefore not even testable. So I've tried to illustrate that with the simplest possible example. So here we have a pure function that is something like the view in the model view update. So we want to display some temperatures, temperature values. So this function takes in a temperature value, in this case it's just an integer, and then displays a GUI for that. So there's not even any interactivity going on here. It's just we statically render a div with some styling, and then we bring that temperature value into string form and display that as well. And now there's an additional requirement that these temperature values fall into one of two classes. There are normal temperatures, which are fine, they just display on screen as text. And then there's too hot temperatures. So here we have this too hot predicate. And in that case, the requirement is that we want to emphasize this temperature display. Here we decide to do that by giving the div a red background. And now this is a pure function, which means, or which should mean we can easily write tests for that. So we do that. Here we have a test for one case where we did want to display the temperature 22, and then we expect that to be a div with the string 22 inside. And then there's the other case where we pass in 183. We expect 183 to be displayed, but then we also expect this background to be red, like this is a too much of a temperature. Now these tests work, and they can be automatically checked, right? But still they're very bad tests because they test an aspect of the implementation. Because the requirement in itself, so the specification, you can say, just mentioned we want to emphasize too hot temperatures, but here we decided to implement emphasis as the red background, and the test also refers to the red background. So now here we don't have any chance to later make it different, but equally valid decision of maybe emphasizing by giving it a red border or displaying a little exclamation mark next to the temperature. These would all, I think, be perfectly valid solutions for the emphasis requirement, but the tests would go red because they are too specifically tailored to an implementation. And these kinds of things happen all the time in genuine UI code, I think. Or at least that's my experience. So there's this paper from 1980, which I think nicely illustrates what is going on here. This article describes three classes of programs: S programs, P programs, and E programs. And it defines S programs as those programs whose function is formally defined by and derivable from a specification. And then there's P programs in the middle, as a middle ground, and on the opposite end of that spectrum, there are E programs, where it says the third class E programs are inherently even more change prone. They are programs that recognize a human or societal activity. And I think that's exactly what's happening here. So if you take another look at our little example, I think we can easily identify an S part, so an S program part here, which is this too hot function. I think it's really easy to specify that formally, right? And you can to check it with the test or even. But then there's this red background, which is an implementation of the notion of emphasis. And the notion of emphasis is a human or societal thing, right? It's very hard to formalize, I think. So you would have to check or you would have to come up with a formal specification that both captures red borders, red backgrounds, and exclamation marks, and so on, which are all valid implementations. And I think that's pretty hard to do. And it also depends on what is surrounding the element, right? So if you want to emphasize this small little temperature display, but there's a lot of other widgets going on the screen at the same time, then I think maybe just the red background might not be enough. You have to do more. And also these notions of emphasis, they change over time. So many years ago, when people were not that familiar with graphical user interfaces, yet, to just sort of general public, you would maybe have to do different things than today, where people are in front of their computers all the time. Right, so these things change, they're hard to specify. And to sketch out where I want to go with this graphically, here's a big oval that stands for our entire UI application. And I think in general, these UI applications are e-programs, so they're hard to specify things in their entirety. Now, it doesn't mean that all is lost, right? We deal with this situation in the same way we deal with most architectural problems, and that is by modularization. So that's what MVC tries to do, for example. So we split the application into a view and controller part. They are usually strongly coupled, so that's the inner red circle oval. And that's an E part, and therefore has to be tested manually. I think just like in general in most cases. And manual tests are costly. We want to not have. And then there's the model part, the green part, which at least has a good chance of being an S part where we can have a precise specification. And they're therefore better suited to automated unit tests. Now, the red part is still quite large, right? And our goal is now to make this red part even smaller. That's why I suppose we take to another pattern from the object-oriented world called model view model, carry that over into our functional world. So here we push the e-program part into just the view, and we design the so-called view model as an S program. The view model is a description of what's happening in the user interface without talking about concrete visual representations. And we'll see that in a few minutes with a concrete example. Now, to implement this pattern, we need library support. We need a UI toolkit that allows us to write as little genuine UI code as possible and make the glue code between the view and the view model as small as possible, and in the best case, trivial code. That's something that React, the original React, didn't quite allow us as much as we would like it to work. So that's where React C comes into play, which I'll now introduce in more detail. Okay, so here we are in a closure script environment where on the left I have write some code, and on the right we see the result of that in the browser window. So React C is a library for browser defined, and React C is sort of programming model in that model, combination model. So you have some things that we call items, that's a unit of composition, and items can have a visual representation, and they deal with state, or they have state, which means they have implicit and implicit value associated with them, which they can read from and write to or update. Here we see already the simplest possible item, which is a primitive, and that's nil. So that displays on screen as nothing, as you can see on the right, and it also doesn't do anything with state yet. The next step are strings, so like this hello world string. That has a visual representation, and that's just itself, where it just displays the string on the screen. And but doesn't do anything with the state yet as well. Now, one step further is to have there's a namespace DOM here, which comes with all the DOM elements, such as div, and that takes as much first argument an attributes map, which we can, for example, use to give this a red background. This is an item combinator, which takes in an item, right, such as this string, and then wraps that in this corresponding div element. Now, this div, or most of the topic elements, they also allow you to combine multiple items into one. So if we have two items, I and J, and they both on strings, then we can display them next to each other with this div as well. So here we display hello world next to each other. but still nothing about state yet. So now we'll look at a simple button. And that button also takes a special attribute as its first argument. That can have a special attribute, something like onClick, which takes an event handler function as its argument. And these event handler functions are pure functions going from state to state. So here is that's the point where you can update state. So here we give this lambda with the argument is called state, and we want to build an increment button. So we want to update the state by adding +1 to it. And the label of this button should be just increment. So now we have a button, it says increment, and it also works. I can click on it, and I have to tell you that it works, but you don't see it yet. Right? So we use state and we update it, but we don't display it yet. That's where another item combinator comes into play, which is called dynamic, which takes a function, and that function in turn takes the current state value and returns an item. So we can do something like this, where we take the state and then return an item. So we already have an item in the form of this button. But now this argument can be used, for example, to display as the label here. So we put this integer here with state, which is called state, into a string. We save that, we see, okay, we already clicked the button 9 times apparently. We do it again, we see that it is indeed incrementing a value. Right, now, for a slightly more elaborate example, let's quickly get rid of all that or not. Let's put this into a separate. Let's give this a name basically. So this is our increment button. That's done basically. So this is we'll hopefully not have to touch that anymore. But now we want to have a large application that deals with tuples, so a set of 2 values, and the 2 values are integers, and we want to have 2 separate increment buttons for the 2 components of that tuple. So first of all, I'll have a button that resets this this tuple. So again, we write a button with onClick handler that doesn't care for its argument, always returns 0, 0. And that is the reset button. So save that, we should see that, right? If we click that, nothing happens because we don't display it yet. That's what we'll do next, but not by using, by going from start again, but reusing the increment button. But if I write increment button here now, I think it displays this tuple. But if I click it, I think it will just crash or whatever, because incrementing a tuple doesn't make any sense. So we want to have the increment button. So the increment button is fine, but it's in the wrong context at this point. We want to have that be responsible for just a part of the current state. And that's where another bread and butter combinator comes into play with, which is focus. Because we notice that in, say, 90% of the cases, the relationship between a parent component and a child UI component is that of a lens. So where we have a get which takes from a large value a smaller part, and a putback function which puts in a new small part into a larger structure. And that's what focus works with. So focus takes as its first argument a lens. Well, we already included a lens library for that. So there's lens first, or the first part of the tuple. And then focus as a second argument, it takes an item that works on the smaller part. And if I say that, or if I copy that for the second part and do that a second lens, save that, we should see 2 buttons or 3 buttons with the reset button, and they both work on the individual parts of the tuple. You can verify that by having the state also be printed below. It's a raw form, right? So here we see the right button works on the right component, left button works with left component. And resetting means just resetting both to 0. And now the React C library comes with a few more combinators that also work with concepts like effects and actions and subscriptions and messages. But in most day-to-day work, these few combinators that we saw, Doc dynamic, all of the DOM elements, and focus, they are enough for 80 or 90% of your UI application. And I'll now illustrate that with a larger example, the phone book. So as a starting off point for our little phone book example, I already defined a text field component, which is something a bit like the button, right? So with dynamic, we get to the current text, and then we display an input field where the value of that input field is the current text, and on change, that is one of the handlers like on click. We want to update, and what we want to do is take this event, which is an option second parameter to this event handler callback, and from that we can get to the target and then to the value. So this is just using the DOM API basically, and we set that value as the new state. And here I just display this input field, and also I have this little debugging device here, which just prints out the current state in its raw string form. And then you can see the isolate state, which is another combinator that I didn't go into before because it's mostly used as here it's mostly just used in a demo where I will set the state to a completely new context. So this severs the state of everything that comes below from everything that comes above this top level, which is in this case. And here we can write state values that we want to work with for this demo purpose. So here we say we want to work with this hello state. So if I refresh this page, we start with a hello string and a text field. And now we can type here and see the state change in our little debugging view here. Okay, so now this is our starting off point, but we want to now make a bit more structured application that deals with phone book entries. So our model, we first of all define our model, completely devoid of any UI concerns. We have a record, so we have an entry. So this is our main model, and then we have a little constructor here, say for an empty entry. That's our simple model, and now we want to build a UI for that entry, also for a single entry now, just with the help of the text field. We do that by introducing another item. We call this entry item because entry. We can also say here model is entry as a comment, and an entry item displays just div with these two parts, phone book and name. So there's one part where we have a name label, which is just a string. Main string embedded items. And then we want to focus on the first part of our record, and the record accessors are already valid lenses. So remember, focus takes a lens. So this is called entry name, right above here. And the entry name is a string, and that can be dealt with by our text field. Let me do the same for the telephone number. If I save that, it will not work because I have a string here, so I'll have to start with something like the empty entry state. Right, so this is the raw string display of our entry, and here we have the GUI file. So name, now it's an empty string, but if I type something here, my name, my telephone number, then the entry is actually manipulated. Now, phone book is not just one entry, but a series of entries. And we'll just say that we don't introduce another direction here. We just say sequence or a vector in the closed case of entries is now our phone book. And that means we'll have to have an item dealing with these sequences of entries. So let's call this the phone book item. And here we do something slightly different. So here we first need to get hold of the state, which we call entries. And now we have this. So entries can be 1, 2, 3, or an arbitrary amount of entries. So now we have to apply our DOM function, which is also variadic, to an appropriate amount of items. So let's do that. So we apply this DOM combinator to now a sequence of items. So, and the sequence of items, of course, is derived from the sequence of entries. So we can map over the entries here, or rather what we do is we map over the indices like that. So here we get an index. And now we want to do something like this, right? So entry item here. But now the entry item has to be responsible for just one part of this entire sequence at that specific index. And that's also possible by using focus with the appropriate lens. And that lens here in our case is called at index. Okay, now we can see that our state is now a sequence of these 2 empty entries. Okay, here to here and the other from here to there. And already our GUI is displaying 2 entry items on top of each other. So if we say my phone number is this, my phone number is something like this, then that manipulates our phone book appropriately. Now, this little dance of calling dynamic and then apply to some div and then using an at index lens, mapping over the entries with range count and so on, that's quite a common pattern that appears quite often. So you may imagine whenever you have as your state a list of something or a sequence of something, something like that has to happen, probably. So we can just extract that into a combinator of our own design. So let's quickly just copy that over, make this into a function, and we call that map item. So and then we do basically the same thing here everywhere. Let's call this the axis, and we apply a div to that. We go over the axis and then call that z index, and then entry item is replaced by our parameter child item. And then our phone book item, of course, can again make this more concrete by saying that's just map item of entry item. Now, our phone book is not quite complete, right? So we started with 2 entries and we can manipulate these 2 entries, but we cannot yet add new entries. So that's what we'll do next. So we define a phone book item. And that just calls, or that just wraps phone book item with another little button. And then what do we want to do when someone clicks this add button here? Well, of course, we want to add an entry to the phone book, and in this case, we just inline here. So we say concat our phone book, which is a series of entries with a new list, just holding the empty entry. So let's use it also. Button item. Here's a button, and if we click that, we see our state changes. And our GUI already also reflects that, right? So this is something new here. Now, what I want to really do is introduce you to this view model pattern, the functional view model pattern. And which sort of view model is a model in between your view and your actual domain model. So the view model captures aspects of the UI, but not talking about concrete representations or concrete visual representations yet, but have that be a bit more abstract and still therefore be better testable also. And I will introduce that by introducing another requirement here. So adding new items is fine, but if there's lots of entries, and maybe you have a situation like this, right, where you have some empty entries already, and then you added click the add new button. You don't really know what's happening on screen. It's very confusing. Our new requirement is whenever we hit the add new button, we want to highlight, we want to emphasize that newly created item. right? And emphasis already, I talked about it before. We can just capture the notion of emphasis as a black box for now. So we say is an item combinator emphasize, takes in an item, and then, well, for now, our implementation is just that we have this red border, right? So, and then from now on, so this is our little, small little view part that cannot, I think, be tested automatically because the notion of emphasis is very vague. Something human has to look at that and decide if that's emphasis enough or if there has to be something different happening. So I think this is not testable automatically, but it's also very little code, and I try to isolate that and have it decoupled from all the rest as much as possible. So what I'll introduce now is the functional view model. And so we have our model, so our domain model up here, that can stay as it is, but now I want to also write a view model. And that view model now has to talk about which entries do we want to have emphasized. It doesn't talk about how it's emphasized, but just which ones, right? So here we have another record. Let's call this entry VM for view model. And that has two fields, the entry VM entry, so that's the actual domain entry here. And then an entry VM emphasized flag, which is just a simple field. And we can again define an empty phone book. And as a little helper function, I will define a de-emphasize function. So this is just a pure function on the view model, takes in an entry and returns an entry where the emphasized flag is set to false. And now I will also want to fulfill the requirement that, well, when a user clicks on the add new button, there's one new element or one new entry appearing on screen, and that one new entry should be emphasized. So none of the others. So if one of the others was emphasized before, they should all be deselected, so to speak, or de-emphasized, and just the new one should be emphasized. And that's something I can easily just capture in my view model. That's nothing like that. That's not a view concern per se. It's a view model concern. And so there are many ways I could have this constraint be implemented. In this case, I just opt for a smart constructor. So there's an add new entry smart constructor. So it takes some entries or a phone book, you can also call that. And it constructs a new phone book, which has a new entry. Here we do de-emphasize all the old entries and then add a new emphasized entry to that, right? And now, so this concludes our little view model. And these are all things that can be automatically tested. They're good candidates to do that. Okay, and now that we have this, we still need to write a GUI for that. But that should now be trivial, I think. So we already wrote this little emphasize helper combinator down here. We also need now, let's put it somewhere here. So now we need a new entry item for our entry view model. And we do that by get to the current state, which is an entry view model. And so what we can do is just to reuse what we wrote before by focusing on the entry. And we already have a UI, an item for entries, which is this entry item, right? So that would work. But of course, we want to also now incorporate this emphasized flag, which I'll just do by seeing if that is set to true or false. And then depending on that, we either wrap this element in the emphasize combinator or the combinator on that, just to check if everything is going according to plan. Yes, so this displays our what we wrote before, the entry item, and depending on this flag here, it's either emphasized or Right. So now we also need a phone book item, which again we can just map item with our entry item 2. But we're still missing our add new button. So let's quickly say there's also a phone book with add button item number 2. And again, this is very formulaic. Just reuse the phone book item 2. And then below that we have this button, which on click adds a new entry. We can directly refer to that function as is. We now have that button. Can write something. We immediately see, okay, this is the blue bordered entry is probably the one we just added. Right? And if you click it again, that focus switches to the newly created item. Again. So to quickly recap what we did here. So first of all, we started with a few primitives such as the text field. We defined our simple model up here, right? And we could already immediately write some UI components for this entry and phone book model. But now that we also have some requirements that require us to talk about complicated, intricate UI concerns. That's the point where we introduce a view model to decouple these concerns, or to decouple the S parts of the program from the E part, or make the E parts as small as possible. So we introduce the view model, which now doesn't talk about these vague notions. But it talks about them, but in a way that just pushes the actual vagueness out of that view model. And so that is amenable to tests. And that's what I actually write tests for in my applications. And then the next step is to write GUIs for that view model. But I hope I could give you a good enough insight into that. And what I wanted to illustrate is that the code then is actually quite simple and very trivial. So all of these items here, they just follow the grain of the view model. And there's really nothing going on here. So it is also the nicest piece of code, I think, is something like this add new button, which is just, well, it's a button and what is its functionality, but something that we already defined in terms of the view model down here. And now I think a test that checks for the functionality of this add new button is now superfluous. Well, there's really nothing that you have to test here, I think, which is not yet tested in the test that corresponds to add new entry itself, so the view model part. So that concludes my little talk. Thank you all for listening, and now there's a little bit of time left for questions.
Thanks. Great, I'll put Marcus in. Oh yes, that is what it has to be. There we go. Can you hear us, Marcus?
Yes.
Perfect.
Hello.
Okay, we have I think we have 2 minutes for questions, unless you want to stay later. And then
Sorry.
let's do another round of applause so that you can hear us again. Anyone have questions? Oh, yes.
Well, first, thanks for the nice presentation.
You hear that, Marcus?
Yes.
Okay, while I couldn't quite follow the development of the code, in the last part, it looked like almost like rewriting the code that had been written previously rather than directly extending it. So that seems not particularly modular there. I was wondering if that was a presentation effect because you were building up, or would you have, in a real development, would you have already set things up so that you could more easily add code without replacing, or is it a feature of the system in its present form?
I think it's a bit of both. So I did reuse the entry item that I wrote for the without the view model code. I did reuse that, but I didn't reuse the mapping over the list, right? So I prepare the demo in that I had this map item combinator, extracted that before, because I knew that later I would have to use that to make the demo go faster. But I think that's just normal functional programming there going on. So what recursive allows you to do is to find these looser coupled combinators like map item or like the entry item that you can reuse later, but it doesn't it's no guarantee, right? So if you write something and then your view model or your requirements change and you introduce this view model in direction and stuff is just organized differently than what you had before, then there's really nothing you can do about that. Maybe you find some small things that you can reuse, but there's no guarantee, basically. So it's just, so what you saw was just pure functions composed together. So that's the issue that you have everywhere else as well, I think.
Any other questions? Okay, I think that concludes it, Marcus. Thank you for the talk and staying for the Q&A. Sorry we didn't have more time. Okay, we will reconvene at 2. I think lunch is right now in the same room, and we'll have a good session. All right.
Yeah. Yeah, I have
I knew that was
I didn't expect that. Yeah.
My unit door has been.
Yeah, I was saying you don't. If we look at
But I don't think service. And I think when you get I heard that. Yeah, I don't even
Right, you woke up to it.
I think he is.
I was like, I've never been talking to him. Working on the from all the it's like a single mainframe and it's manually updated. Yeah, so anyway, I was like,
I've never said it's like a whole solid.
Yeah, it's like a top thing, for some reason, I don't know why.
He's all this.
It's not how he found it's there, subconscious.
Yeah, like it's like this is, yeah, he's
It's been around like 50 years. 20 years ago, they decided to upgrade to 41 address space. And I was like, that's insane. It's
Why you even talk about?
Yeah, anyways, I was like, I decided to then use those. So I was like, I'm never gonna have the chance to.
yeah,
And it was okay. I was there for like 42 days. Well, no, it wasn't. It was fine. It was just that like, I literally started and that's the second area. SPJ
for the faculty.
Job rack up on Discord.
Because we
And then responded to just because like, I've been working on words where they have a background in logic, like programming instead of. So it's kind of applied and
I will.
yeah, so that was the interstitial.
No.
Is kind of
Maybe 7 days.
They're like,
You exhausted me, Joseph. Sorry about it.
They were telling me about the system and I was just like, this is
So.
It's
But I'm not really helping him, like the information, I'm the one being supervised. Yeah.
the certification.
But because
The problem with
we're doing web
people
some stuff.
is that
And
often you
the
have
key
people
is the chair of
just
standard.
organized code. They don't optimize things themselves,
So
but
he knows a lot of the
reorganize
stuff
code
about assembly, like
to
this kind of
triggers.
information.
And so you have to find a fix
Be
point.
supervised to know how that thing is
Running.
Yeah, but
Like,
look,
But you don't have
how
But
that.
no, that's why
I know. But
the thing is, every single process,
really-
so
yeah,
basically
well,
you say, okay, one thing
like
is not recorded.
sitting in
I
the.
don't, and like they kind of basically say in the specification, you can reorder code whenever it doesn't change
The point I'm making though is that
And also,
that separating, so but one type of people out from another type of
well, we
is also
have one
important because you have this thing of,
outgoing.
oh, this, if this people triggers,
Finishing, I guess.
then if this pattern triggers, then that enables another pattern, which then might enable the third.
Yeah, but we don't talk about, so one thing obviously, which is an issue, is
It's a lot.
what we don't check, for example, for cars, that's
Yeah,
optimization. So they
Yeah, a lot.
easily.
Like how?
The
Magnitude is more.
the tricky thing is the
For
semantic part of
example,
it.
just to
That,
get
but,
my
because I also don't, I don't expect anyone to specify that, oh, this is the optimal.
Goes all the way
versus
to
like-
very
But it still needs to be semantic
just
serving.
very that kind of small
And
things.
that's,
It
once you have
goes
a number
all
of
the
people
way up.
that sort of interact in that way.
Each one is systematic. So everything is very serious. It has to
Yeah, sure.
go through many approvals.
When they are not run as separate passes.
No,
How was it going? In class,
Exactly.
how happened
So
with the forest
Even
department of
compiling
Australia?
also work done, etc.
How did you
That code is actually doing
Yeah, I just gave them to your friends.
Very nice.
I don't know how
internally.
good that
So,
was. I don't even know whether they're still alive. Yeah, I just yeah.
Basically,
Were there for many years.
and I
Yeah, it's really because
No,
but as far as I looked at the, so we left the
several
compiler,
months for my sea freight to
Done.
arrive.
what it actually did, in which order.
Yeah.
And then we use that.
Yeah.
So basically.
Well, I managed to get a little bit of that.
Yeah, so you get a kind of,
Yeah.
trace of the compilation, right?
Usually
Something to me.
I always
is just like.
it's not the same about because it was just
Yeah,
hard, I
yeah.
guess.
But it does
Because I
tell us
I
what
have
it.
so much
Yeah.
stuff.
I remember.
And maybe
so many
that's
years.
enough for
Yeah, so many books. I have
Yeah.
my coffee equipment.
Oh,
Basically, great.
okay, that's worth picking, yes.
Yeah.
Yeah, when I
But yeah,
But
been there
yeah,
for
I
like
guess
7, 8
the
years.
sort of, like, my overall point is more that this thing of,
Like,
okay, so the reason we want to write formal
Australia.
specifications, the
And I did.
reason we want formal verification of things is we want to eliminate bugs, right? We want to write bug-free code, bug-free compiles. But
But
then
I guess the thing is that
Will you summarize?
once we have a specification, we define a bug in the compiler as not adhering to the specification.
Nothing broken?
But that's equivalent to saying that if I have a
Okay,
compiler
nothing
without
happens.
specification, then it has no bugs, because there's no specification.
No, because I the entire box, moving box.
Oh, yeah, the entire.
Which I think that thing will take maybe half of the actual key content.
Oh.
So it's not individual boxes, it's just a big
Against the
wooden.
specification.
I
It's
think
not
it's
just the specification again.
It's a bit pricey, but
Yeah.
just for the
So,
sake of
even the
my books and
I
stuff.
feel like in a sense that they moved to Australia like
Equivalent of replacement
it doesn't arrive and also
Sure.
stuff like that.
Yeah, that could
The
help.
point I make
Yeah,
is
yeah,
that
it happens.
a compiler without
But yeah.
any sort of formal specification of any kind can still contain bugs according to against its expected behavior,
Yeah.
which is this informal.
Yeah, currently I'm
And
going
then,
to
okay, so you can
to
write
the
specification.
end of next year.
But that can also be
But
argued
that's
against
actually the big
expected
question,
behavior.
what I'm gonna do.
And what's it- and so you
optimize the compiler to actually optimize it.
and that's kind of
touch, right?
that I was getting at, right? It's I have yet to
Smart is in the standard body and
convincing
it's
argument that it's easier to write specifications than it is
and
to
also
write
it's from
to write a
Imperial.
compiler.
So it has lots of.
And that's
No,
what
it's not easy.
No, exactly at all.
No, so I don't say that it makes
No,
but the thing is.
Yeah, but
I-
it's fine.
like in
It's for
our
a lot of
context,
things
like
like
we have a rule about the properties of the contract.
yeah.
It can be like
And
in
you
the
want
ones
that rule
what you like
to
and that's
transport
where you
to
go
the
like
properties of
make
the
sure the
compiler.
people are nice.
Yeah,
But
Okay, so you're taking.
yeah.
Oh, okay, so you were also taking
Yeah, post that
problems
is
about
like at least for me.
the source program. So
In that only
Works, but like
transports, if I have
it was
some
yeah,
guarantees
this is
about the
fine.
how the
Like,
compiler
yeah.
will use. So that is basically the connection.
Yeah.
And
You know you don't lose anything if you
I mean,
then
it's totally down.
but that's also even if I have
Exactly, yeah. No need to deal with teaching supervision, funding.
it shows there's a semantic equivalence
Yeah.
between targets and
possible while
the bugging the specification.
while it can last, you know. But yeah.
Well,
Because
okay.
It's difficult to decide.
No, it doesn't matter, but then I
what,
couldn't.
yeah, like.
These pipeline, this pipeline is required that the specification.
Even industry is like.
If something is related according to the specification, then it also has to be semantically.
Change
So,
of every
so
company.
there's one,
It's really not that big of a
the one thing we have the problem, but there's another way around, like the
It's a bit.
buggy, the pseudo buggy trigger was that the
Yeah,
specification
yeah,
was
it's just
narrow,
between-
too narrow.
Yeah.
And then the,
And
said basically,
that's the
okay,
part
this
that I don't
part
really
was
want
not
to
according to the specification.
One,
then they realized,
and
oh,
also secondly, it's like how
It
long
wasn't
it takes me
specification was
to
too narrow.
get familiar with the
Which is sort of
technical stuff.
another way of
Yeah, that's true.
saying that there was a bug in there's a bug in the whole infrastructure So like, not necessarily, like,
Yeah,
it
you're
could
right.
also be a block that was never really triggered by any real code, right?
Well, that was-
Yeah, but it was in this case, right, yeah.
Yeah,
You know, like,
the
but
concept, everything was correct, apart from the specification, the specification didn't allow you to do something.
Yeah,
Well, but like, we still stay unimportant for like.
But the real,
Stay
the real problem, or the real challenges in
Right.
this part of this also is the more collaborative, path is like is
like all the stuff and
it's
Yeah.
kind of difficult then to
Yeah.
Yeah,
You have to
exactly, and then you go back.
put information about the whole view of the problem.
Whatever you do,
into the
like
thing
you-
that is.
You can use
Yeah,
it
yeah,
out of
yeah.
what-
So then,
No, but that's
Or
because
not use it, but
you're essentially doing sort of micro
Yeah.
verifiers, right? Yeah. And
Yeah.
once you do,
Depends how
like,
stressed
once
you
you do
are
that, then
about,
any sort of global information becomes.
Well, exactly,
But
that's
but
kind
it's
of-
not,
Whereas
you're
if,
not
right,
stressing
global,
on being
global
productive.
information is much easier. But
But
then you have the problem that, well, yeah, but then the,
Paper,
yeah,
or at least I think he was not paying for education, our education for so long, and this is PhD, get the salary, and it's the documentation is also about the solution.
Yeah.
Everyone that's PhD for months, postdocs for months, 2 years, so cool thing.
Yeah, so it's basically kind of contract, customer contract.
There's I've been working in the blockchain space for the last 7 years, writing compilers for.
But you're lucky like that you had that.
No, it's, I'm on a sabbatical right now, so I'm, but yeah, 3 different blockchains, 3 different languages. I had it for the last.
Really not.
One of the things I noticed
And then 6 months.
is
being
a thing
productive,
that-
And then you see that the.
So always surprised me about smart contract languages, which is that everybody cares about correctness. Very few people care about whether we can strip away an instruction here and there so that people pay less gas.
It's just the kind of stuff.
It's all about correctness because that's the thing that costs billions of dollars. Any bug in a compiler is an attack vector.
Exactly. Because I realized.
Yeah,
that
no, that
from
is-
previous experience.
I was interviewing with a company,
It was mostly because I
in a
got bored of
completely different
working alone,
space.
so like.
And one of the, so okay, well, I would work on smart contract languages. And then he said, okay, so you've done a lot of observations. I said, no, hardly anything. I've done verification. But it's all about eliminating attack vectors. And you're surprised to pursue gas. No, people don't want other people to run away with $1 billion worth of cryptocurrency. We should. Yeah.
All the time. Lots of the things in the knowledge proofs. Yeah. More efficient your knowledge proof.
No, I don't.
I'm here.
To get lucky.
Oh, right, yeah.
And make sure you get lucky.
Yeah, yes.
What's that?
It's, I mean, it's like very basic. So we can solve the very basic like expression and everything, and it can do quite tricking, like simple object, right? Oh yeah, this door doesn't open from the outside. I mean, I think now it does because I didn't put it on anyway.
Yeah, I think I will just leave it unlocked. So that
Now the fire exits and leave it.
Yeah.
Please.
Yes. So I have to stay here now, is it?
If you want, you can move on. If not, you can stay.
I'm just trying this. So this Zoom, don't basically
Everything is.
everything already set up.
Yeah.
Yeah, shit, everything's set up. Okay, that's not
Yeah.
So I just sit like somewhere there, then sure. Oh, I see.
For me, I just like set over here in case there's anything I feel for this thing.
Oh. Yes, either province. Also a language, but yeah, I built in Europe, I built the language in now I'm just looking. So someone else, people did publish like
Yeah.
yeah, and he wrote the language, now I'm just discovering. It's in the dictionary. I think it's a very nice transition because I already have knowledge of it. Now you follow me to the image.
Yes. I think I started getting interested because actually I was from since the years. And I went from office content and the profs started talking about all these things. And I was like, oh wow, so interesting. So I just go and explore.
You take one of the ones.
Sorry?
You take CS one of the ones.
Yeah.
Yeah. Profit so fun. Okay.
So you were interested since the start.
No, I wasn't. I was trying to do a different one.
Is it the Source Academy? Yes.
Yeah. Are you going home now?
I think I'll like attend the other workshop.
Sure.
Yeah, wait for me.
Oh yeah. Nice to meet you.
Nice to meet you.
And he won. All right. Yeah. Yes.
Okay.
Okay.
You did see us, did
Yeah. You see that around here. Oh, okay, around here? No, I don't think so.
okay. So there you go. I couldn't see it. Drop down.
Hey, this is.
Very responsible.
Okay. Michael, can you hear us?
Absolutely, good morning.
Oh,
He said
we cannot
something.
hear you.
Pretty good.
Oh, there we go. Okay, wonderful. I believe we missed, I don't think, because I definitely recorded the second. Yeah. But I think we missed the first one. Okay. Yeah, unfortunately, but I think that this, I don't know, I'd have to see what it was, like a cloud. Yeah, but I'm almost certain we missed that first talk, so. Yeah.
Didn't you recall on her computer?
She might have, I don't know, yeah,
Yeah, you can ask.
so. Yeah, then I guess I'll just remind you to. If any, yeah, if when someone asks, just tell them it was my fault. Okay, because it is. Yeah. I think it's fine.
And show them a subset.
I think it's fine too, but it means that the website, our functional architecture website will have a gap in it. That's what I was more sad about, yeah, so. Okay, Michael, do you need anything before I can start record, I'll start recording the cloud and we close it? Oh, we have lots of time.
No, your hotel sockets, the thing falls out if you even touch it.
Yeah, I have found that most of the sockets in Singapore have been loose.
The universal ones. Or do you
Yeah, the
use
universal ones.
Yeah.
No, I have an adapter, the adapter is tighter than most of the sockets.
You're talking about the wall sockets.
Yeah. Guess I don't have much to do over here.
Mine is the fuses.
Okay.
Or maybe it's inside. You have two screws. Tri-wing screws.
What time is it for you, Michael?
A fuse. No, it is in French. No, yeah, it's current limit, so it will melt when it goes over 30. In Dutch, it is will stop.
Oh, easy.
Okay. OMB. British petrol stations will sell this sample.
With that?
Sample.
Oh, yeah. With that.
Yes.
Yeah, and then when we buy solder. They still use the one.
The 60.
Yeah, they don't, in Europe is really actually getting long again. Without need. No, not the opposite. No.
Oh, without, yeah.
I had to ask the one without because I should have used the one with, and they were surprised. That's not. They say it's under the years.
So what you can use, it's there. You fix your own stuff or make things.
Yeah, I try. No.
Okay, it's dangerous in soldering, it's gonna reduce, say, petrol, it's like the fuels and things. Really.
Ah, yeah, yes. Decided that. Okay, to get our proper set up unit structure and all that. And my piece though, so 4 out of 9 minutes to go. Oh, they're not learning at the moment.
It's a good mandatory part of your parenting plan.
Yeah.
To learn.
You learn the key expression. I really like, but my son is, for example, it's rule follower. Let's put it away. So if I leave the flux, the base of flux, so stick it in the jar. But if I need the jar open, go like that's toxic. I know I have the window open right there. So I'm sure he's not gonna learn to solve the even providing he wants, you will not unless.
It's career path might be the inspector.
Yes, exactly. I finally got my hands on the fancy stuff. Do you know these things? They're pros. BC White is the brand, and they are white wood. Sorry.
Are you trying?
That's basically the typical IoT switch, something that I buy the cheapest ones, provided that I know what chip they're running into their reflection.
Okay, but are they ESP32?
Yeah, that's probably actually no. These ones now most likely run on the or something else.
Even switch stresses.
The BT something. I forgot. I should have the name of it. They still do these modules there. Sweet big K. See, I tell you what the use. Decade. It's the equivalent. It's still an arm. Equivalent to yeah, I mean, it's amazing. It's just it's okay. Like it's a big company. It makes a lot of them. They do not have all this. make it clear. Anyway. That's what. And what I'm saying is that so these probes are really good because they are so these are pogo pins, very sharp. And this one. It's well, in Australia, I think. No, probably from yours. So, you know, it's just we expect it to be the typical thing that move around, and but the way it actually works is that the top is really heavy, and this is very, I want to say flexible, but flexible in one direction. It goes down, but it does not flex this way. And if there's a pogo pin in the bottom, so with extreme precision, you put it and it stays. There's a magnetic metal base and magnetic thing. So, like also this is probably the older version. Yeah, like it can be as bold. Again, this is now at this point. It's just the size of the probe. Yeah, and it's very sharp. You can even keep your phone some spare ones because they might break. But again, you put it, it's not going to move. Spend too much time trying to yes, like little probes and the things to grab the little feet, and like it's such a pain with that. Like so like it's the thing where I'm too old to use shitty tools. In the sense I don't have the time and patience to be good despite the fact that the tools and shit. I need zero time. I need to use the good tools, otherwise I'm never gonna do it. So yeah,
Opposite of come wow.
Look at this active group logo.
Oh,
You need to check down your pins or something to find the
yes, yeah, but that's. I mean, this I think wasn't. It just wasn't bad. It was like, these are basically connected to a serial port, and you need to turn it on or reset it while the program is running to make sure it catches it, and then refreshes. I think I have another one that is still a pain because it's sideways, so it's really hard moving those to reach between the two layers.
At least they're so bad you can still reach.
I have
a
a lot of photos of PCBs because like typically when I don't know what to do, I just open it up, take a bunch of photos, put it back. And then if I wanted to check something, I'll just look at the picture of the PCB. Like this is an old what was it, a security camera.
Yeah, it's like infrared LED.
Yeah. And I think it's reachable, operable. Maybe one day I'll have time, maybe not. But I have a lot of, if you search for PCB.
So this is from what, is it? Like, what teaching sorry, it's
I do a little bit of the home automation things and
home automation.
home automation like switches and
What protocol I use?
well basically these ones will be all Wi-Fi. Because what I do is I buy the cheap ones at the shop with fundings in Australia. And then I just check, like usually when I'm the shop on the phone, what module they run, and if it's one that I know, I'll buy if it's cheap, refresh what the entirely is there.
I only have a bunch of smart bulbs, and they all use Zigbee protocol, and they all relay the signal. So it's like if you can live with a 1 second delay, it's fine.
Absolutely.
But 1 second is actually a long delay for a light switch.
You're like, does it work? It's just enough to press it again and you.
But it beats like rewiring the house. So yeah.
Oh no, of course.
We're gonna have a pin session today. Apparently. Okay, we'll get started on the dot.
Oh, it's this. The whole session.
Yeah.
Big questions.
Big questions. Yeah, you guys.
Teaching.
Great questions. Okay, so to begin our afternoon session, Michael Sperber from the Active Group is going to talk to us about 6 years of functional FUNARCH, training functional software architects. Let me make sure I start this recording because I want this to go well. Okay, it is recording, and Michael, do you want to take over the presentation?
Sure. Well, good morning. Well, it is morning here. I hope you can hear me fine.
We can. Actually, maybe I should mute this.
Okay.
I'll mute us until Q&A. Okay.
Okay. Excellent.
All right. Take it away.
So I'm going to talk to you a little bit about teaching people about functional programming and functional software architecture. And first, to give you a little bit of background, I run a company called Active Group, and we've been doing functional software architecture for more than 10 years, doing project development using functional programming. And we also have some consulting business, and we also do software reviews, and we also do training. And that's what I'm going to talk about today. We also run a blog on functional programming, and that's just about transitioning to bilingual. So we have some English language posts and more coming up. And we also run the site functional.architecture.org, which tries to collect some information on this and also hosts the permanent record of this very workshop. If I can slip in a little ad section, we also run a developer conference in Berlin. So if you happen to be in Berlin on March 13, I welcome you to come to Bob, which also co-located with ICFP a couple of years ago, which is not solely dedicated to functional programming, but has a strong focus on functional programming. So I want to take you back to the year 2018. And as I said, we were developing software using functional programming. And we also tried to get into training. So my personal background is I was at the University of Tübingen for a long time and did a lot of teaching. That's kind of in my blood. But the problem is that in the commercial space, we were teaching like 2 classes a year, if it even got to that. And so it was not doing very well, and we were not reaching many people with that training. And so we got together and thought, well, we have to think of some marketing ploy in order to make our trainings more popular, to bring that to more people. And then we remembered, or we discovered an organization called the International Software Architecture Qualification Board, the ISAQB, which happens to be also based in Germany, even though it operates internationally, at least to some degree. And what they are is they are an association of companies and individuals that develop trainings in software architecture and have like a common marketing site. And we thought maybe we could latch on to their success and to their marketing power, especially because the ISAQB's basic training, if you will, the foundation level, which I'll get to in a minute, is on the career path for lots of large companies, their software architecture roles. And so I think the ISAQB has given out on the order of 25,000 foundation level certifications, and that corresponds to about 25,000 people who've gone through their training. So I sat down with Nicole Rauch at the time, and I think we thought we had this brilliant idea. We were just going to slip in a curriculum on functional software architecture as part of the ISAQB's offerings. And we didn't think, we just kind of put together our knowledge of functional programming and the theme of the ISAQB of software architecture. We thought, well, these things go really well together. But these days, I'm kind of reminded of an interview that Ozzy Osbourne gave when he said, well, when they were starting out, or when he was starting out in music, he wanted to make music that sells well to a lot of people. And he didn't know what to do because the music he liked wasn't going anywhere. But then he discovered that horror movies were really popular at the time. So he said, oh, we need to make horror music. And so really we try to put together these ideas of functional programming and software architecture, but we we didn't really have a comprehensive or coherent idea of what that was and what it meant to put those two things together. I mean, there were a couple of ideas kicking around, like the fact that you would write a bunch of pure functions, of course, ideas like parse, don't validate, where you use data to represent the results of computations that might fail, and that would include feedback, that you would generally try to be declarative, that you would think about the laws and properties of your domain logic, that you would try to do without effects if that's possible, and if you have to do it with effects, then you kind of push those to the edges. Things like that, right? But these were just a bunch of loose ideas, and we put together a first draft of a curriculum based on those ideas, but then the ICQB's feedback said, well, you really need to connect these ideas to the ideas of software architecture that people who are likely to go through your training would know. And we hadn't done that. We neglected to do that, and so we decided, well, we really need to look at how the basic training works as part of the ICQB. And so their example exam has this question as the first one. We thought that's going to lead us in the right direction. What is software architecture? What's the definition of the term software architecture? But in case you can't see it immediately, the correct answer here is C. There are many different notions of software architecture. And well, that wasn't very helpful. So we kind of decided that we were going to focus on these three things, maybe on specifically on things that you need to do with software that is long-lived and that gets large. Specifically software that gets so large and so long-lived that it requires multiple people or even multiple teams to work on it. And we really, the ICQB reminded us that it's not just about writing software in a vacuum, but really it's about writing software that fulfills requirements, and mostly requirements that are actually being posed by humans. So not primarily blockchain, maybe. So and if you think, well, of course you're writing software to requirements, I'd invite you to take a look at any of the programs of recent ICFPs and try to spot the papers that actually try to fulfill requirements. So this really is different from sort of the culture, at least the recent culture of functional programming. Now, I think when most of us, especially in the functional programming community, think of requirements, we mostly think of requirements on functionality or functional requirements. But of course, there are many other kinds of requirements. Just to give you an idea of what the view of the software architecture community on this is, here's a very popular book on software architecture out of the Software Engineering Institute at Carnegie Mellon. And it says, well, functionality doesn't have anything to do with software architecture. And you think that's weird? You're not the only one. I also think it's weird, but it is a pretty popular view among many software architects. But I mean, if you kind of wonder, what are they talking about if they're not talking about functionality? They're talking about, for example, this taxonomy. So there's an ISO standard on the different qualities a software system might have. And of course, you can formulate requirements on all of those qualities. And the one at the top, functional suitability, that's functionality, is only one among many. There are many others, things like reliability or security or safety. This is, I think, the older version of 25010, which has been amended since then. And also things like portability or maintainability. Now, what you're seeing is a slide from my colleague in the ISAQB, Markus Haver, who did a survey on, well, when do these different qualities come into the focus of a software project during its life cycle? And not very surprisingly, functionality is always first, right? When people write requirements documents for software that has not yet been developed, they think of its functionality first. And then maybe once the software project has started, then they remember, oh, the software that you develop crashes all the time. Maybe we need to think about reliability. Then the users complain. You think about usability, and so on as you go down this ladder. So the further you get down this ladder, the more time passes and the later do these qualities come into focus. And that's, of course, a problem for this school of software architecture that says that functionality is not important for architecture because, well, at least some aspects of software architecture really need to be done early, but you don't have the requirements early because the relevant qualities are not in focus yet. What's especially problematic is that if software is really, or software architecture is about long-lived software, the thing that really is about long-lived software in this taxonomy of qualities is this one, maintainability, which of course is not user-facing, so it comes into focus late. So it comes into focus late. At the beginning of a project, there might not be budget for it. So it's kind of, you kind of need to square the circle as a software architect. And a lot of software architecture is just about trying at all costs to kind of gather the requirements for all those qualities that come after functionality in order to be able to design something at the beginning of a project. But of course, that's kind of a fool's errand, because a lot of those qualities, first of all, well, I mean, people don't want to talk about them at the beginning of a project, and some of them are kind of quantitative. So you might know at the beginning of a project that you have certain performance requirements, and you might even know that you need to fulfill, 1,000 requests per second, but there's no architectural blueprint that will like deterministically get you to that exact number, of course. So typically what you're going to do is you're going to design your software system, you're going to put it into production, you're going to measure how fast it is. And if it's not fast enough, you're going to change it. And we'll get to that aspect of change later. So the software community at large has produced lots of knowledge and books and techniques and technologies to design software systems at large, which is, of course, also the subject of this workshop that we're all in. Now, all of those, basically most of those books, unfortunately, are based on the object-oriented tradition of software architecture. And we really don't have a tradition of talking about long-lived, large functional software projects, at least not when it comes to how do you design them. If you look closely at this picture, you might spot a lambda, though, and you might say, well, maybe there are books, and indeed, by now, there are books on functional software architecture, and there are two, but really, you can count them on one hand. So there's the book by Chris Hansen and Jerry Sussman on software design for flexibility, which really is about software architecture, even if it doesn't have architecture in its title, but it's about designing long-lived software systems. And there's this other book which really has functional architecture in its title, but both of those books weren't available at the time that we were thinking about designing this training. I'd also like to point out that even though both books are ostensibly about functional architecture, they really are based on specific programming languages, functional programming languages. So the left one is based on Scheme, which is not going to win many friends among the sort of applied software systems community. And the right one is very specific to Haskell, and a lot of the techniques presented there might not apply in your functional language of choice. So we really don't have a body of knowledge on the general principles of software architecture. And so we kind of said, well, we're just going to do it anyway, and put together the ideas for a curriculum for the ISAQB, first in 2019, and a revision came out in 2023. So we just kind of made it up as we went along. And you can, if you're interested, you can just download that curriculum. It is copyrighted, but it's free to download, and you can also implement it. It's just if you want to offer that certification, then you need to get on board with the ISAQB. So just to give you a rough idea of the context of this, so I talked a little bit about the ISAQB certification pipeline, which starts with a basic training, which is the same for everybody. So it's typically a 3 or 4 day course with a multiple choice exam at the end. And once you've passed that, you can move on to the what's called the advanced level, which is not one specific training, but there's a wide variety of things. So so this diagram is from the time when there were 17 different curricula on various aspects of software architecture. And I think by now there are 20, and functional software architecture is one of them, I think. Since then, we've also designed curricula on domain-specific languages and formal methods, if you're interested on that, which are, of course, natural successors to the functional architecture. These things also, these curricula typically also then inspire 3 or 4 day trainings. I'll get to ours in a moment, so anybody, again, is free to implement those. And there's a much larger exam at the end where you're supposed to spend a week on a larger architecture problem, and then you actually talk to people to get your certification. So the foundation curriculum is, well, it's kind of, I guess the structure looks kind of generic, but I wanted to put the link to that on the slide, so it's published. Just as the FUNARCH curriculum is. So it introduces the basic concepts of software architecture and kind of follows the life cycle of a software system from original conception, the formulation of its requirements, its implementation, and then the analysis and assessment of software systems that already exist. The FUNARCH curriculum is like that, right? We target people who don't know functional programming yet. We really need to tell people about the technologies that we use in functional programming, and again, because they're different ones than the ones that people know. Then we talk about functional modeling, that's the main part of it, and functional macro architecture, and I'll get to those aspects. So again, anybody can implement this, and I can imagine very different trainings on this. My co-curator of this curriculum is Lars Hupe, and we're kind of waiting for people to come in with vastly different ideas from the ones that we had for our training. So, but so far there's only hours, so I can talk about that. And we do, as I said, we do 4 days. And the first day that we do is just an introduction to functional programming. So it's not really part of the software architecture training proper. And then on the sort of a day 1, we start on software architecture, and really the focus is after an introduction to Haskell that we focus on domain modeling as data. And so that's kind of something that we discovered over the years, that we really need to frame this in a way that we're doing things as data. And so I'll get into that more. So we'll do domain modeling as data, and eventually we also do a complete macro architectural example. And again, I mean, there's various aspects to that, effects and events, and I'll get to that. But the common theme is sort of for our functional architecture training is everything is data. And I think that's the proper way to think about functional software architecture in general, and also makes for a nice distinction from the rest of the software architecture world, which thinks data modeling is kind of unimportant and trivial. For a short moment, I want to get a little bit into day 0, which is the introduction of functional programming. I mean, I've talked about this at length at other events, but a lot of us, I think, have been brought up on this classic book in functional programming, Structure and Interpretation of Computer Programs, the Purple Book or the Wizard book, which is one of the great books in computing, I think. And the book was originally written for the intro course in computer science at MIT. So, and it's just very compelling. I hope you feel the way that I do about this. Since the early 90s, I think it came out in 86 or something originally. So it uses Scheme, a wonderful functional programming language. You know, MIT, the pantheon of computer science. It's really well written. It has great examples. There's a lot of stuff, a lot of great examples specifically for abstraction. And it is genuinely multi-paradigm in that it tells you how to implement all kinds of programming paradigms based on that substrate and scheme. And so it's easy to, from there, branch out into different ways of programming. So what could possibly go wrong here, right? All of these things together need to make for a successful introductory course in programming. Unfortunately, that's really not the case, because while all of these ingredients are sort of great for if you're already an established and confident computer scientist, these are wonderful, but they don't work very well for beginners in programming or specifically in functional programming. Again, I've talked about this at length, but the main reason for that being that it's based on examples. So it presents great examples, which make the book so compelling, but it doesn't really tell you any methodology about how, the learners could then solve the problems of those examples themselves. And so they're left with figuring that out themselves. And that, only, in my experience, only very few people succeed in sort of figuring that out themselves. And what I hear from former TAs at MIT, it was the same at MIT, despite the fact that they have such smart students, undoubtedly. And so this prompted Matthias Fellheisen's group in the, I think, late 90s, who kind of went through the same experience as I did, teaching at the university based on the Purple Book and failing, that we really need to think harder about telling introductory students how to design programs. Well, and that became the title of their book, and that's really revolutionized, I think, the business, the didactics of teaching programming, and specifically about teaching functional programming. So if you haven't looked at that, check it out. It's free on the internet, and it is, by miles and miles, the most effective approach on teaching programming and functional programming. And not surprisingly, if you've listened to my remarks on our training, it focuses on data and functions on that data. And of course, in functional programming, the functions themselves are data as well. So again, it took me a while to realize, but if you look at it now, I see a book that is an introduction on data modeling, and it's an excellent one at that. I was teaching here at the university at the time, and so over time we produced our own German language version of how to design programs, if you will. So if you speak German, you're invited to check out this book, which is also free to download on the internet and being used, I think, at least by the university here and maybe by a few others. The central idea of these books is something called the design recipe or design recipes, which are systematic, explicit, named techniques on how to design programs. And they're very pedantic, which makes that book maybe not so compelling for established computer scientists because it's so pedantic and maybe a little bit boring. But it really has this very consistent way of designing programs by always going through the same sequence of steps. Each step yields a product, so you don't stare at a blank screen and don't know what to do next. And at the center of it is a systematic data analysis. And from that data analysis, you mechanically derive program templates. And if you go through that, you can very easily construct most of a program or most of a function, and then kind of it has like little gaps in there where you have to fill in the actual details of the problem statement at hand. So, but it's a very gradual construction of a program, and that makes it very workable and learnable for beginners in programming. And as we discovered for the established programmers that we get in the software architecture class, that stuff works for them as well. Or conversely, if you don't do this, just teaching that doesn't work. So the didactics are the central aspect of how to design programs, but there's a couple of other ingredients to that as well. Namely, they developed the Dr. Racket, back then it was called Dr. Scheme program development environment, which is much easier to handle than complicated things like Visual Studio or Eclipse or IntelliJ, which are great, but which are very complicated and they have lots of buttons and menu items. And Dr. Racket is very simple in structure and easy to learn for beginners. Also kind of forces you to do things by hand, so you get some haptic aspects of programming. And with Dr. Racket come specific teaching languages. So when Matthias Fellheisen's group started out, they also started out with structure and interpretation of computer programs with Scheme. But Scheme, as wonderful as it is not a great teaching language. You really have to evolve it to be good for teaching. And you can see some examples here, a little snippet of example code from the last time that I taught the class. So you can see the Scheme legacy and the Lisp-like syntax. But if you look at the things that look like type declarations, those of course are not in Scheme. We call them signatures. There's a record definition form, which is also not in Scheme in that form. And there's a bunch of examples. This example here is about armadillos on the Texas highway, as the Racket project originated in Texas. And so it has a little bit of data modeling, and it also has, if you look here at that signature that you see at the top, also is the first instance of dealing with state in functional programming, where you don't just have a method mutating state, but instead have a function that gets the state before and producing the state after. So that's part of the intro course. So we discovered that really is the best way to introduce even, experienced programmers to functional programming, is to go through a very, very fast version of the intro course that we originally designed for beginning programmers, and then switch to then we switch to Haskell. We could conceivably stay within Racket, and I kind of dream of a version of this class that uses Racket for the rest of the class. We did want to introduce one more programming language to just show people the variety of functional programming languages. And Haskell is kind of diametrically opposed to the Racket-based teaching languages in many ways. So it has I mean, aside from the fact that it doesn't run in Dr. Racket, but we run it in Visual Studio Code, is in that it has a completely different idea of syntax. It has a type system. It really has to be pure, so you need to talk about monads. You can demonstrate things like concurrency and parallelism. Also, what really is nice about Haskell there is that the Haskell language server that you can use within Visual Studio Code is just super excellent for beginners, and actually better than the language servers that they're used for, that the participants are used to for their favorite languages, like whatever, Java or C# or something like that, because of things like inline evaluation and so on are really compelling and nice. We also have a Scala version of this training, which works equally well, but the language server is not quite up to that level, and the language is a little bit more circumvent about the concept that we want to talk about. I want to talk about data modeling a little bit. So when we joined the ICFP, we thought, I implicitly thought that data modeling has to be a central theme for everybody doing software design, and especially long-lived software design. But over time, we discovered that that is so not the case. And if you think, well, shouldn't the object-oriented people really care about, designing their objects and doing things like object-oriented design and object-oriented analysis? If you get into that community, you'll find out that all of these things are dead. They existed once, but they don't anymore. Could talk about that at length. Interesting subject. But really, data modeling, I mean, we are, especially if we're doing things like Haskell or F#, we always think about things like algebraic data types, which combine sums and products. But if you look at software out in the wild, it often does not have sums. And partly I blame relational databases, which don't really have a notion of sums in there, but I think there are other reasons as well. We're not teaching it. So a lot of people don't do sums. And I'm also, and within the ICQB, I'm also in the group that designs the foundation curriculum. And we recently, just last year, put in a learning goal on data modeling. Stefan Wehr, who's also a functional person, so we're kind of infiltrating that organization a little bit. So we put in a learning goal on data modeling. We said, well, software architects should know the difference between sums and products. And that caused a little shitstorm. We got feedback from a number of software architects who said, well, I've been designing software all my life without this sums and products nonsense, so how can that be important? But it kind of died down when Stefan and I wrote a blog post on our functional programming blog. And so we're going to see where that leads. So that learning goal is just being implemented just now. Of course, in functional programming, we're not just worried about data modeling, the structure of the data, but also the semantics. And in functional programming specifically, we do something called combinator libraries. And, I always like to point out this classic paper from ICFP 2001, or I think 2000, on financial contracts. And it starts out on page 1. After giving a few examples, says, well, obviously you should design a combinator library. So this is folklore in functional programming. And of course, it's a great technique of using abstraction and sort of semi-systematic design to get very powerful data models that anticipate not just present, but also future requirements. But even though, at least, Simon Payne-Jones here, one of the authors of that paper, I think who wrote that sentence, surmised that everybody knows about combinator libraries, obviously within the functional programming community. Almost nobody outside of the functional programming community knows about combinator models. And so we really haven't done our work doing outreach, which is, of course, one of the themes, hopefully, of this workshop as well. So one of the central aspects of our training that sort of comes up again and again and again throughout is that we evolve data models into combinator libraries. And we use the financial contracts as an extended example, which actually is a great didactic example as well. I also want to talk a little bit about functional macro architecture. So we do a little card game with all aspects, sort of a little back end and a front end and UI and things like that of the Hearts card game. So there's a complete, miniature application architecture there. And one of the things, again, that seemed evident to us as we were designing the application and then designing the training was, well, we started with data modeling, of course. What's a card? Suit and rank. What's a trick? The stack of cards in the middle. What's the hand? The cards that people have in their hands during the game. Then so that characterizes sort of the static entities of the game. And as we also need to talk about the process of the game, that, you know, whose turn is it next and so on, and what happens in what sequence. And we do that with designing events and commands, which are also, well, I'll get to that in detail, we'll get to that in a minute, which are also about data. And then we get into the domain logic, which is, first of all, about sort of individual steps, and then how to arrange those steps into a coherent gameplay workflow. And then there's a couple of other aspects to that application. Because we have a web-based front end, we need to serialize and deserialize these events and commands between the back end and the front end. There's also a little functional design in there. And then, of course, there's the front end itself. And I believe my coworker Marcos has talked about sort of UI design and toolkit design earlier at this workshop. And so those ideas kind of got into that as well. So using events and commands. So what's an event? An event is a record of something that happened in your application domain, represented as an object or as data. So there's this whole idea of event-based architecture, and that was developed independently of anything functional, but it really goes well, of course, with that functional idea, and that you would have a data type that describes the things that happened. There's also this data type for commands, which expresses wishes that something might happen by some party in your application. And then you would typically have, for different sort of agents in your system, you would have functions like the ones at the bottom that tell you how to turn the sequence of events into what's called a projection in event-based architecture. So some kind of object or cache or database that will let you answer the questions that your application has efficiently. Like, you know, whose turn? I mean, of course, you can always kind of slog through the sequence of events to answer all your questions, but it's more efficient if you have sort of a state object somewhere, like the table state or the player state that you see here, that tells you what cards are on the table, you know, whose turn is it, things like that. And this really nicely, you know, evolves into sort of the application as a pair of functions. I mean, there's, well, at least two kinds of functions, where you kind of have the rules of the game, which we call the table, so that enforces the rules of the game, and then the players that slap cards on the table in order to play it. And the table, well, let's start with the players. So the players emit commands, so the desire to make a move in the game, and the table decides whether that move is valid and then communicates the consequences of that command as events. And so you kind of have this cyclic or circular process that is symmetric. Now, one interesting issue is, well, how do you implement those two things, right? How do you implement this cycle? How do you implement this idea of going from events to commands and the other way around? And of course, as functional programmers, we say, well, of course, you do a function, right? You feed in a command on the left-hand side, and out comes a list of events. And in order to do that, though, you need to refer to a suitable projection that will let you answer the questions that you have, in order to enforce the rules of the game. And here's the early version of that, and you can see that, you know, you can do it in a functional program, but especially in Haskell, it's kind of awkward, because a single command might produce several events. You know, the first one might be that I don't know if you can see my mouse cursor, but if you can, you know, you pretty quickly get to the point where you determine that a legal card has been played, but then there's more consequences of that command, and they depend on the intermediate states that you need to compute. And so within that one function, you have a sequence of events that you go through. And of course, in functional programming, they need to be separate objects. And in Haskell, you need to give them separate names. I numbered them, but of course, there's a significant danger that you're going to get the numbering wrong, especially if you insert something after the fact. And so it would be so much nicer if you could just have a variable and update it. And so if you think, well, of course, we can have updatable variables in Haskell, we just do a state monad. Well, you can do that too, and we tried it. So we've now gone through 30 iterations of this training, and what you just saw was the first version of that function. And here's a later version where we figured, well, we're just going to put the state monad in there. But try to explain the state monad to somebody who's really new to functional programming, who's just, I mean, we're on Wednesday now, and we started learning about functional programming on Monday, and it just doesn't work. Um, Especially, I mean, you kind of depend on sort of an abstract version of state, and why you need this special device? It's just awkward, and it just goes downhill from there because you get into the business of having more effects than just state. We tried monad transformers. That is just, don't do that if you're doing software architecture. You might try doing effect libraries, which introduces more advanced concepts than you're prepared to teach, so that doesn't work. And we eventually settled on this idea. Well, we're going to have a monad, but that monad, the operations of that monad are not technical in the sense that the state monad is technical, but they refer to things that happen in the game, such as, recording an event that something happened. So the table is communicating what happened in the game, but also asking the table, is the current round over? Is the current play, is that valid? Things like that, right? And then you can express the game, and then you can express the game flow just as a monad. You don't have to worry about the sequence of events. And that game monad is just implemented as a data type, right? So this is a standard sort of free monad style data type. I'm sure you can talk to me about its disadvantages, but this is something that people can actually do, especially as it plays really nicely into this idea that everything is data. I mean, it starts with the word data right there. And so we have this idea that even the processes in your application can be modeled as data, and that it's beneficial to be able to manipulate them, as opposed to a typical object-oriented solution where this process would be a method that you can't really manipulate after the fact. So you have this idea of workflow as data. This really works. People can design this monad themselves. So this is actually an exercise to design this monad. It's resumable, which you need for that web server. You can talk about things like continuations in that context from that introduction to monads. So this is after an introduction to monad, where we also do a free monad style thing to do a little database language. Let me approach the end here, but I think we're doing okay. We also talk about serialization, deserialization, which again sort of reintroduces ideas of combinator models for the errors and the decoder themselves, and things like functors and duplicatives and monads follow nicely from that. And so one aspect that we really stress is the sort of algebraic means of structuring your data using semigroups and monoids as properties, and this little hierarchy of functor, applicative functor, and monad. Now, once you do this, you really teach this idea that everything is data, and you present this entire application architecture. So we did that many times, but oftentimes, again, I taught it this week, and people kind of, we've done the complete application. They asked, but where's the architecture? What, you've taught us a lot of things. They're interesting, but where is the architecture? This doesn't seem like the architecture trainings that we're used to. And this always baffled me. And I want to get back to the beginning as to that software is about long-lived and large software architecture, long-lived and large software systems. Now, if you ask software architects, well, what are the activities that you do as part of doing long-lived and large software architecture? There's this prominent school. So one possible answer to that first mock exam question would be, architecture is about making decisions. So I think that first comes from a book by Mary Shaw a long time ago. So here are Simon Brown and Uwe Friedrichsen, two prominent software architects in that community. And they say, well, so architecture is about big decisions that you can't reverse later and that you have to get right. And learning about that, I always thought, well, is that really what we should be doing in architecture? Because I was brought up on the works of David Parnas, who kind of invented things like modularization in the 1970s. And Parnas's, seminal paper on modularization says, well, your modules should hide design decisions, especially the ones that are difficult to make and that you might change later, so that you can change them later because the actual decision has been hidden. And of course, so in a way, I think modern software architecture has given up on the original goals of David Parnas, and maybe it's up to us to rehabilitate those ideas. And the way we could do this is, well, software architecture, an important aspect of software architecture is we're trying to, as you're getting into long-lived software systems, So here's a book that I like to cite, especially in functional communities. I don't know if you've seen it, the Green Book on Structured Design from 1979. And the authors were trying to figure out what it is with long-lived software systems that you need to do. And first of all, they asked this question, where does the money go as you're developing a long-lived system? Where do you need to spend the money? And they discovered, well, maybe not surprisingly, that the money goes into not the initial development of the software system according to the initial requirements, but into changing the system later according to evolving requirements and into maintenance. So the money is in the change. And what's in the way of that change is a phenomenon called coupling, which are interdependencies between the different parts of your program that require you, as you change module A, to make corresponding changes in module B. And that is a problem to this day, more than 50 years later. Now, I like to argue that it's much less a problem in functional programming. So my coworker Marcus, that you've heard earlier, likes to say, well, we're doing decoupled by default because immutability and abstraction boundaries really make for much less coupling than you see in object-oriented programs. And therefore, you get a lot less of the problems that you see in software architecture. And these problems really are very prominent. So the software architecture at large operates under the assumption that if you develop what they call a monolith, which means one executable, as you ship that and develop it, it is by default highly coupled and highly unmodular, which is why that community came up with a new term called the modulith. You need a special term to say, well, no, this monolith is different from all the other monoliths. It is modular. And they're just now getting, it's fairly recent, they're just now getting in the business of thinking about how to do this. In the meantime, this community, the only recourse they saw to solving the coupling problem was to do microservices and introduce all the problems of distributed systems. So I really need to wrap up. We'll get there. So let me sort of wrap up on this idea of functional software architecture that has emerged from our work on designing the training. So it's bottom up, where a lot of traditional software architecture is top down. It is late, so the things that traditional software architects do early in the game, which are the big decisions, the macro architectural decisions, get made late in functional programs because you're doing bottom up, and therefore you can change them more easily. Everything is about data modeling, and if you caught it in passing, it kind of nicely goes with that idea of functional programming. We really do the functional qualities first, and we kind of, I think we should have like a t-shirt that says, proudly functional first, not just in the sense of functional programming, but that it's okay to really focus on the functional qualities. Because we have lower coupling, we can make the changes required to address the other qualities later in the game. So we've done that about 30 times now, or I think 31 since past week when I taught that course again. We get fairly uniformly positive feedback. People really like it, but they're really exhausted by day 4. We get FP newbies, into a place where they can, design and implement a monad in Haskell in 4 days. So, but there's really this dearth of literature, and I really need to spend some time on writing up more of the stuff that we develop. Generally, we need to talk more about to the software architects out there, and hopefully that this workshop here is an opportunity to do an outreach in one direction. Teachability really matters, not just in that you're designing things for the classroom, but I think if you design things well that work well in the classroom, that usually gives you hints as to how you should design them at large as well. Maybe you saw that at play when designing this effects or this monad for the game workflow. I think that's a good idea, a good starting idea to actually design these systems as well. There's always improvement possible and ongoing, so we collect feedback. I just did a bunch more slides, even though on the 31st iteration of this. And as some of the reviewers correctly pointed out, I need to think about a way to collect data about the aftermath and how participants were able to use the stuff that we taught them. So hopefully we can report on that in a couple of years. But until then, really, this is an established thing now, teaching functional software architecture, and I hope you'll be interested and maybe inspired to do that also in your community, or maybe not even in your community, but in the adjacent communities. To tell people about it that don't know about functional programming and functional architecture yet. Thank you.
Okay, we're unmuted. We technically, you can hear us, Michael?
Yes, I can.
Perfect. We have 1 minute, so let's take 1 or 2 questions. Does anyone have questions?
Sorry.
No questions? Okay, I have a question. Can you go back to the game mode?
That one?
Yes, if you, but can you show the if then else branches before this?
That one, yes.
No, before this even more.
This one.
Yes, this one. Could, I was looking at this and I thought, but you could do this recursively, right? Where events and states that are numbered would be recursive iterations. Have you tried this?
What? Say again?
Okay, so you have event 1, state 1, event 2, state 2, and event 3. But could, like, the problem is you want to generate these states, but you don't want to use a monad. But I was asking, could you do that through recursive invocations of this function or a child function? And
So
then just accumulate these into a map, or I'm sorry, into a list.
I think you probably could, but it would require a slightly different representation for the state in order to track where you are within that event sequence, if that makes any sense, right?
Yeah,
And
that
you
makes
could
sense.
do that, but I think from a design standpoint, it would be more difficult to teach because what we're doing is that table state type that you're seeing there is just kind of, pointing a camera, from the ceiling onto the table. So it's just what you see. Introducing what you just said would be to introduce sort of a technical element into that table state. I suppose it could be done, but the beauty of the table state object as it is, it corresponds to the physical reality of the game.
I see.
Which is, right.
Yeah, this code looks to me like some kind of scan. But that's just my functional programmer eyes. Okay, any other questions?
I agree.
Actually, I wanted to also discuss the code. I really like the effort you put into designing and revising this example. When I ran workshop, I had to go through the same process, and I think there was a slide before this, like a even earlier iteration, the one that had events, or maybe let's go back to the one you had before.
Here's the events.
I remember, I think you said something like you can represent it as a state and a set of events mixing.
So that would be, I think it would be the slide, right?
Oh yeah, I thought there was the one, and I think you said, if I remember correctly, that you have the problem that many events will have to influence this state again. So a little bit like Jeff was going, I think, to me, that feels like that tells us that you need to break down that big function into smaller functions. And I would expect that where you said that you want to represent the state of the game as seen from the top, so essentially what branch you are in that expansion kind of tells you where you are in that moment of playing the game. I don't know. I mean, that to me feels like more functional because everything is a function.
Yeah, that's actually a feedback I get maybe 20% of the time during the training as well from the object-oriented people as well. So I think it's justified, but and when so it's not just your criticism.
It's good to have the discussion.
But so it's this function essentially, right? But it doesn't get, all I can say is that from my viewpoint, and then when we look at the result of splitting that up into multiple functions, it doesn't get nicer in the sense that that this really, I mean, not this formulation, but the one that we actually end up with is something that you can kind of read, from the top to the bottom, and you can recognize the game workflow. And if you split it up in multiple functions, it's much more difficult to kind of relate that to what's going on at the table. So as the software architects say, it's a trade-off. So you're right, but I like this version better.
That's right.
Yeah, this also keeps everything in one space, like you're saying. Yeah. I see it.
Yeah.
All right, thank you, Michael.
Thank you so much. You have a great workshop, and a great day and a great ICFP. Sorry to not be there.
Yeah. All right, I will stop the recording. Yes. Perfect.
Yes, that's it.
Yes. Okay. Tom, are you online?
So.
Tom, you are muted.
You talking to me?
Oh, yeah, sorry.
I was talking to Tom Ellis, our next speaker.
I think I should be unmuted now.
We can hear you.
That's great.
Okay, I'll introduce you and then start the record. Yeah, I can start the recording now. And then it's all yours. Okay, so Tom Ellis of Grok is going to talk to us about his construction or his new library on effects called Bluefin. Tom, you have the floor.
Thanks very much. Yes, my name is Tom Ellis. I've developed a library called Bluefin, and I'm going to give you an experience report of using that in production. So what is Bluefin? Bluefin is an effect system for Haskell. What is an effect system? Well, an effect system is a library for giving you access to a variety of effects. What is an effect? Well, that's a very good question, but at the very least it contains these effects: state, exceptions, I/O, streaming, and perhaps many others. And an important property of an effect system is that it delimits the scope of effects. So you can see where effects may or may not happen within your program. From a functional architecture point of view, what does this look like? Well, we like to design our programs as a collection of loosely coupled components interacting in well-defined ways. That's our holy grail of architecture. How does Bluefin help here? Well, Bluefin is an FP solution to this problem. So in the FP world, components are just functions. And loosely coupled means that there are few dependencies between these functions. And well-defined interactions, well, the interactions we have between our functions, between any components of our program, arise ultimately from applying functions to arguments. And the arguments that we get to apply to these functions were just the results of other functions. And in a typed FP world, everything is well typed, so we can make invalid states representable. That is to say, we can ensure that only certain interactions are possible between various components of our program. In the Haskell world, the venerable effect system is called MTL. And in the MTL world, you passed effects at the type level. So if you wanted a component that performs an error effect, a sort of an exception-like effect, you would have a monad error constraint at the type level. Same for state. If you want to manipulate a state of type ST, you incur a monad state constraint on the definition of your function. Now, a modern effect system in Haskell, or a recently developed one, Effectful, takes a similar approach. If you want to be able to raise an error of type EX, well, you have a constraint at the type level that allows you to raise that error, and similarly for manipulating a state of type ST. Now, Bluefin takes a different approach. In Bluefin, the ability to use an exception effect is represented by a value level argument called exception. This is sort of an exception handle or a capability to throw an exception. In order to manipulate a state of type ST, you take something at the value level. This is a lot like, for example, an ST-ref or an IO-ref in Haskell. It's a state ref that you can manipulate within your operation. So Bluefin and Effectful are very similar, but they have this difference in terms of how they take effects, or how effects are passed into a function. These are both called actually IO wrapper effect systems, which is something I want to touch on very briefly because it's, I'll say without going into much more detail, it allows predictable performance and it allows resource safety, and that differs from the older effect systems like MTL. But I won't say much more about that here. So what's the difference between constraints and arguments from a practical point of view? Well, my hypothesis is that passing effect handles as arguments will reduce the practical amount of coupling that you see in your program. The challenge that I get in response is that passing effect handles will get very tedious. If you have many effects in scope and you have to pass them as arguments, well, you don't really want to do that. You just want to infer them from the environment. There is a problem with inferring them from the environment, and that is that you get worse type inference. You kind of have to cross your fingers and hope that the constraints can be inferred. And if they can't, you have to do a lot of plumbing manually, which is much worse than just passing arguments. And in addition, you can only have one effect of any type in scope at once. So you can only have one state int effect in scope at once. What happens if you want to manipulate two ints? Well, you just simply can't. So what does my anecdotal evidence say? Well, my anecdotal evidence bears out that I was correct. Well, I'm the developer of Bluefin, so take that with a big pinch of salt. But I like passing these handle arguments as values. And I haven't found that it gets tedious at all. In practice, what do we see? Well, I really have mostly up to 3 effects in scope in any given effectful operation. Sometimes I might have as many as 5 effects in scope, but that's quite rare. And normally, if I was getting a lot of effects in scope, I would simply bundle them up into a product type like we would do for any 2 or more data values that often occur together in our program, put them in a tuple, put them in a record, and pass them around together. So my experience has been in developing a compiler-like implementation, very straightforward conceptually, and we all know and love it. We take some text source, you do a variety of manipulations on the AST that you pass from the text source, each of which may have its own state that you manipulate during that transformation process, and in the end you get machine code out. I found in this kind of problem that effects were not that useful. It's a sort of one and done program. You run the program and it's either correct and you get a result out, or it fails. And you don't really need to handle effects in a sophisticated way in this kind of program. If I was writing a long-lived server program, for example, well, I think it would be very important to be able to handle effects, recover from handle exceptions, recover from thrown exceptions in client code, and continue processing. But in a compiler, that I've found that to be less useful, so I haven't got so much value out of that. We do a lot of state manipulations, of course, but even that hasn't proved to be tremendously more useful, because we can just use the standard Haskell pattern of state threading, passing around a state value into a function and the new value out of the function. What I have found, and what surprised me a lot, is that streams are extremely useful. And a stream is where you can yield values of a type from your operation for processing elsewhere. How would you normally do that in Haskell? Well, in order to return a sequence of values from a function, you'd return a list. So this is how you do it in the list monad in Haskell. Here we're iterating through the values of 1 to m and binding them to I, then 1 to n and binding them to j. We enforce some condition on I and j, and then from this function f, we yield yet more results based on the values of I and j. So that's what happens in the list monad. In a streaming system, what you do is you do 2 nested for loops, and then you check the condition using when, and then you run an effectful function which can yield yet more values to this stream. If you want to add another effect in this streaming setup, that's very easy. So if I want to do a logging operation, then I just add the logging operation, no problem. That's just another operation in the do block. If you want to do that in a list monad setup, well, you just can't. I mean, there's nothing you can put here to do that. So it doesn't support that. So effect systems, or the streaming provided by effect systems, allows mixing effects in this way, whereas the list monad doesn't. Now here is a short example. In this function squares, I am yielding to a stream the square numbers between 1 and n. So I take numbers from 1 to n, I square them and I yield them. So this produces a sequence of integers. The sum function now takes a stream as an argument, or well, an effectful function which produces the sequence of results. And then it accumulates into some state, starting from 0, all the values of that stream. So what's it doing? It's summing all the values of that stream. And this is what it looks like to combine them. We just compose those operations and run them. So this is a separation of concerns. I can define the function that produces values separately from the function that consumes values. And in fact, I think if we interpret streams as a form of dependency injection, it's easy to then understand why they're such a powerful architectural tool. So the underlying implementation of stream is that it's just a function that accepts a stream handle to A. It's just a function that accepts a value of type A and then does something with it. And what is done with it is deferred. It's a deferred choice that's deferred to this for each block, where you instantiate this functional value with the actual operation that it performs. And in fact, I have a general version called coroutine that not only accepts an A and processes it, but then returns a value of type B. And this is literally, well, a function that accepts this coroutine handle is literally a higher order function. And then we defer until later the instantiation of that operation. So this is literally a form of dependency injection. It's a sort of well-scoped form of dependency injection. Now, I've been converting our code base piecemeal. It started off as a mixture of MTL and transformers, concrete transformers. And I've been converting it bit by bit to Bluefin as the need arose. And I've actually found this very straightforward. So MTL and transformers are kind of interconvertible fairly straightforwardly themselves. And the constraints that the MTL world provides can actually be instantiated by Bluefin constraints. So we can interpret monad error and monad state as Bluefin operations that take these exception and state handles. And similarly, it's straightforward to handle concrete monad transformers and then reinterpret them as Bluefin operations. We can also go backwards. If you have a Bluefin operation, you can handle the Bluefin operation and then reinterpret it as a concrete monad transformer, and then you can go back to MTL. I have not implemented a direct route back to MTL, but that's kind of work in progress in Bluefin, and I'll add that if that proves useful. This is only kind of useful in a legacy environment where you're working with code written in an existing form, but it's very nice to know that that does work out straightforwardly. So finally, to sum up, what are effect systems from a functional architecture point of view? Well, I said it's about defining your program as a collection of components, which are functions that are loosely coupled together. So there are few dependencies between those functions, and that they have well-defined interactions through applying functions to arguments. And in a typed world, these arguments can be well typed in order to rule out certain sorts of behavior. And Bluefin just extends this to the effect systems world. So Bluefin effectful operations are functions, as we expect from any sort of monadic Haskell setup, but not just the data arguments or data values in your program are arguments, also the effect handles are arguments. What does this give us? Well, it gives us better type inference. And once we have better type inference, we can take streaming seriously, because streams are rather difficult to use in this implicit type level parsing setup. And once you can take streams seriously, then you have this wonderful separation of concerns or dependency injection kind of setup, where you have a very nice way to break your program up into these communicating components. So I'd sum up Bluefin as saying it's a lower friction approach to existing architectural best practice. So if you're interested in finding out more about Bluefin, well, you can check out some of the resources here. Firstly, if you want to ask me a question, you are welcome to open an issue on the Bluefin GitHub repo. And I've also collected together a number of resources, talks and articles about Bluefin, if you'd like to read or watch anything more there. So you're welcome to do that. So that's all from me for now. And if there's time, I'll take any Q&A.
Okay, let's go ahead and thank our speakers. Tom, we have plenty of time, so is there any questions? You're also, Andrea.
The quote there is a functional core imperative shell. And sometimes when looking at effect systems, I feel like we're putting the imperative back everywhere. We track them, the effect system help us track them either on types or on the arguments. But I would be putting imperative and state back everywhere. Does that make sense? Is that a question?
Is that a question?
I mean, like in terms of best practices in functional architecture, right? That's the last what you said in the last slide. Is it putting effects and not restricting where you put effects? So putting effects everywhere, is that a good thing or is that a bad thing?
So perhaps controversially, I would say I don't have a problem with imperative programming per se. And I would say that Bluefin allows you to write in an imperative style. But even Simon PJ famously said Haskell is the world's best imperative programming language. I think we should embrace that where it makes sense. What we really value from the functional world is making invalid states unrepresentable. And I would extend that and say, make invalid behaviors unrepresentable. So what Bluefin and effect systems in general do is they allow you to circumscribe the range of effects that may occur in any given context, and that is what we want. It's not that we should eschew imperative programming per se, but what we want to avoid is unrestrained imperative programming, where we can mutate anything in any location, where we can throw an exception anywhere. That's what we want to avoid. So I would say the best parts of functional programming, from the point of view of design and architecture, is the ability to enforce these well-defined interactions, and that comes from making invalid behaviors unrepresentable.
Thank you.
Any other questions? Yeah, I have a question. So you said the magic words that the performance is predictable, and that piques my interest. So I am wondering if you have measured any kind of program that uses Bluefin when you're passing, like say 1 or 2 effects versus when you're passing more than 7. And I'm specifically curious about this because I know that GHC has, I think, or generates different calling conventions when there's many arguments to a function. So that should intersect with the design of Bluefin, because in extreme cases where you have lots of effects, I think you will now have a slower calling convention.
That makes sense to me, yes. I haven't benchmarked that specifically. What I mean about the predictable performance, I don't necessarily mean good performance actually, but I do mean predictable. And I can clarify or explain more about that. The baseline for comparison would be MTL and monad transformers, where underlying that you are building your effects up from data types, algebraic data types, and then interpreting those data types, deconstructing them at a later stage. That's actually extremely high performance when everything can be inlined. So when GHC can see your whole program, it will actually avoid constructing and deconstructing these data types, these values. When everything cannot be inlined, well, then you've got a big problem because you're doing a lot of very slow work in one module and then undoing the work and interpreting it as some operations in another module. And that leads to well, a big slowdown, but even worse, it's unpredictable. Its performance depends on very subtle behaviors of the GHC optimizer. So these IO-based effect systems, of which Effectful was the first one, don't have that problem because underlying them, they're only ever performing IO operations. So state is an IO ref under the hood, and an exception is just a GHC RTS exception. So that's predictable. It doesn't depend on any subtleties of the GHC optimizer. Now, in practice, they should be also well performing. I mean, they should work as well as any other IO code in Haskell. But with regards to passing the number of arguments, I haven't done any specific benchmarks on that.
Okay. We have 2 more questions. You had your hand up first. Do you want to say your name?
Matthias. Matthias Gergens. Hi, John. Does this at all relate to session types? Like, because session types were a bit more popular like 10 years ago or so. Does it have anything to do with it? Can you
Hi, Matthias. So not directly, but an extension of Bluefin could do that. It's something I'd be very interested in implementing. For session types, you really need to work with linear types, and Haskell GHC now does have linear types. One very interesting way you could deal with that is you could have 2 communicating components that can detect the state of the other, essentially. So you could process a stream and detect, process an upstream stream of values and detect termination of that stream. Or you could detect the moment at which a stream stops yielding values of one type and starts yielding values of another type. So that would be an example of a type session. And I have some experiments with that, and I think it is possible with Bluefin, and it's possible using GHC's linear types implementation. But there are a number of ergonomic problems, a number of rough edges with GHC's linear types implementation. So I haven't really pursued that much further.
Yeah, hi, this is Gary. So my question is, so as far as architectural concerns, and in your talk as well, you talked about the interface to Bluefin, right? Like, what does it look like to use Bluefin? But now, when it came to performance, you also mentioned that it's an important piece of the puzzle that this is like this IO-based at the bedrock, you have IO-based handlers for the various effects instead of the MTL style data types. How closely coupled are these 2 things? Like, could you have, and would it work well if you had a Bluefin that didn't use this IO-based representation for use cases where I can't have IO at the base of my stack? For example, if I'm writing hardware and I want to use an effect system to describe parts of my circuit, but I actually want to, or need to eventually get rid of everything that is not just pure stuff.
Good question. So the short answer is you can do something like that. You can add a Bluefin API over a different implementation. The longer answer is that if you try to do that, you will get into a lot of trouble with GHC's, the way GHC handles these constraints. The only way to get the effect tagging that Bluefin uses to make sure effects can't escape their scope to work out in current versions of GHC is to have what's called an incoherent instance. And that works fine in this particular case, of the particular case where Bluefin is implemented as IO under the hood. if you try to use that to implement a version of Bluefin that uses, say, transformers under the hood, then everything looks like it works. But I think these incoherent instances then end up sending, or can end up sending, an effect to the wrong place. It can send them to the place of another effect that has exactly the same type, but isn't where you intended to send it.
Because the JC specializer gets confused.
I don't think it's to do with specialization specifically. It's to do with how incoherent instances are resolved. And it is that's a very gnarly problem. It's kind of lucky that it works out well, successfully in the way that it does for Bluefin. And that's just a sort of coincidence to do with how the underlying implementation works. Now, in theory, GHC could implement something like set types, type level set types, and then Bluefin could use that and there wouldn't be a problem. GHC would just do the right thing. But as things are, I've kind of hacked type level set types into GHC in this way using incoherent instances, and they work by coincidence, but it makes it hard to extend to other cases.
Thanks. Any last questions? Okay, let's thank Tom again. Let's flood his GitHub with issues to show him that we care about him. Okay, I am the last speaker for 2 lightning talks. One should have really been a panel, but I thought it would be awkward to come back from a break just to have a panel to just leave. So I will just start recording again. And then, yes. Okay, I will just begin. Hi, everyone. My name is Jeffrey Young. I work at Epic Games. You can find me around the internet as DuGNU. And I'm going to talk about, or rant to you about what I think functional architecture is, which you may have noticed many of the talks at this very workshop have asked that question and offered answers, and this is my time to now offer my answer. Okay, yeah, so disclaimer, I don't know. This is just my thoughts. This isn't a paper. Please interrupt me, argue with me. The goal here is to spur some discussion. So if you go looking at definitions of software architecture, and this is something that Michael Sperber also touched on, you will walk through the history of people really trying to define this very nebulous thing. So there is an IEEE standard definition of it that's on the screen. This is actually the old version. There's a new version from 2022, but that's paywalled. So I think it's kind of funny that a standard is paywalled, but I couldn't get it for the purposes of this talk, but I'll just read it to you. So is the fundamental organization of a system embodied in its components, the relationships to each other and the environment, and the principles governing its design and evolution, which I think is a very comprehensive definition. That's not the only definition. There's several other definitions from Martin Fowler and Ralph Johnson. Ralph Johnson's a co-author of the Game of Ford book. So another common, and I couldn't find a attribution for this one, definition is an expert developer's shared understanding of the system design. So if you go ask an expert developer on any system, hey, what's architecture? And they will say, it's my understanding of the system and how it's designed. And I think that what this is really talking about is it's talking about a shared vocabulary, which this website I'm showing is the functionalarchitecture.org website. Please go to it to raise its Google rankings or ask ChatGPT about it. And on that webpage, Michael and I guess me, because I try to contribute, offer a vocabulary for different, techniques and patterns. And I think this vocabulary gets to some of the heart of the previous definition, the shared understanding. But this goes on. So in more definitions, these ones are more recent. Some of these come straight from Martin Fowler now. Is architecture is the design decisions that are made early in the project. Maybe that one's part of this. I don't know. I wrote this. I was sleep deprived on a plane. Architecture is the stuff that's hard to change, whatever that is. And this one is from Martin Fowler in a 2014 talk. And he says, it's just the important stuff, whatever that is. Yeah, go ahead.
No, but I mean, so stuff that's hard to change, that's clearly too encompassing, because I like in my last job, I had to change a data structure that had blown out of proportion, and that every part of the system was touching. Okay, I don't consider that data structure to be architecture.
No, you didn't want it to be architecture.
But it was.
No, but that was just the data structure. That's not architecture. It shouldn't be anyway.
Right. But so my point here is, let's accept this definition. Okay, what does then functional that mean?
Yeah.
What do you mean functional, the important stuff, whatever that is, right? Yeah, so I hear you. I feel your pain. Yeah. Any other comments before I move on?
Well, actually, I have one. The one before that, the stuff that is hard to change.
Yes.
That kind of implies that there should not be any software architecture.
Right, so
just like there shouldn't be that basic reference.
By definition, Cabal is then software architecture.
Yes, by definition, it's so the stuff that is hard to change. A secondary, an implied point in that is I haven't strictly decided what's hard to change. Right? Like at least in my experience, I don't know what's hard to change until we've built something real and have customers, and now I have to go change something and I discover it's hard to change. So it's disempowering, I think. It's somewhat in retrospect instead of a priori of the software project.
There's also here the first and second on this slide, they're also not necessarily the same, because stuff you made early doesn't necessarily mean it's hard to change or the other way around.
One of the things I've discovered just trying to look even quickly at software architecture is not to expect consistency. I think that it's a nebulous concept, which makes, and then what we're doing here is even more nebulous because we're adding on to something nebulous. Okay, so far lightning talk's going great. I'm happy you're passionate. Okay, so I don't know, right? And what I like to do when I don't know is maybe try to define or generate some data to look at more deeply. And this is where I offer an example. And that example is the paper Build Systems a la carte. So I don't know what functional software architecture is, but I believe this is an example of it, right? I can't define it, but I think I know it when I see it. Now, Build Systems a la carte is, I think it's a 2014 paper by Makov, Neil Mitchell, and SPJ. And I just want to read this. This comes from its introduction. I want to read it to you. In this paper, we elucidate which build system properties are consequences of specific implementation choices, right? Blah, blah, blah. And how one can obtain new build systems with desired properties by recombining parts of existing implementations. Recombining parts of existing implementations sounds to me a lot like composition, but that's because I'm a functional programming diehard and addict and degenerate. As a compelling example, in section 5.4, we demonstrate how to combine the advantages of shaped and based pay grade. So moving on, in this paper, what they do is they use Haskell, of course, and they define basically an API for build systems. So this is their data types. They say, well, a build system is really some kind of abstract store, and it operates in response to tasks and all this stuff. All I'm trying to show is just to give you their entire spec fits on one slide. Right? It's one figure. It's really straightforward Haskell as far as the people in this room are concerned, I expect, right? But then, and this is where the functional architecture part really jumps out to me, is they go through this spec and they highlight, okay, well, I have some constraints and I have this new type tasks. And well, if I make task and applicative, this is the kind of build system I get. So they argue that Excel is a kind of build system, which I think is genius, describing Excel as a build system. And so if a task is applicative, well, then in spreadsheet 1, you only need applicative operations, and then that says that you can express the fact that the dependencies between cells can be determined statically just by looking at the formula, but you don't have to compute them. But wait, but if task is a monad, oh, well, now we can express dynamic dependencies, right? And so now cell C will depend on some other cell D, and we can express that dependency. But if task is a functor, well, I don't know, that's a degenerate case, but at least I have the spectrum, right? And then they go even farther, you have to read this paper. This talk could have just been titled A Love Letter to Build Systems à la carte, where they then map out the space of existing build systems in a table using this vocabulary of like the space of build systems that they've built up, right? So, okay, so if I have a scheduling algorithm that's topological, they define that in the paper, go read it, and it uses a dirty bit, then I get make. If I have a scheduling algorithm that is suspending and I have a rebuilding strategy of deep constructive traces, then I get nix. So they argue. But I love this kind of idea, right? Like this, you're taking something, giving me an abstract specification, and now you're giving me a map of the territory, right? I'm oriented. So I want to say that that's the important stuff, right? This stuff is the important stuff. Knowing that I can get different behavior by different specifications of the kinds of functions I'm using to make my build system or my whatever system I'm architecting is the important stuff. The important stuff from this definition, important stuff, whatever that is. So maybe that if you accept a different definition of architecture, you have to argue that build systems a la carte somehow comports to that definition, but I use just the last one. So then I want to say, and here's my big leap of faith, right? Build systems a la carte studied build systems as an abstract concept using Haskell and Haskell's type system. And then I want to say, well, then what functional architecture is it is a way to architect systems by creating an algebra of components, which is what I believe build systems a la carte did. And then it used that algebra to describe the space of build systems. And I want to then make the further leap, if you'll trust me, that is expressing the essential complexity of build systems. And that's what I'm interested in with architecture. I'm interested in the essential complexity. Thank you for coming to my TED Talk. Yeah, go ahead.
Okay, two things. One is a joke. So functional architecture is what architects do.
Okay.
And architects, you can just figure out who that is by the job title.
Yeah.
And you can figure out if people as a function programmer by just asking them, one shut up about it. So that's so you go by that. But actually, something slightly with your system a la carte. So there used to be, I don't know, a long-running sort of fork joke or something that basically the way to do anything in function programming is to figure out how to see your problems that you're trying to solve as a mapping it to either writing a compiler or interpreter or something like that.
Yeah.
And basically algebra is sort of just a more dignified way to say the same thing.
Yeah.
So I think it's actually sort of in the folklore, it's the same answer the folklore gives you in a sense.
Yeah, I think so too, yes.
Okay, so going back to the things that are hard to change.
Yes.
By defining functional architecture this way, aren't you deliberately choosing to define it in a way so that it's less hard to change?
I can also choose not to accept that definition of software architecture.
Yeah, I get it, right? But this is I don't like the stuff that's hard to change argument as I pointed out earlier. Okay. So that like it seems like if you're gonna like. I mean, you're almost formalizing the your architecture if you want, like what you seem to be saying is that functional architecture is a formalizable architecture. It's a formalizable thing at a sort of higher level.
I want to believe. Yes.
Yes, right.
Yeah.
And if that's the case, then stuff that's hard to change is not the right definition of software architecture.
If that's the case, then maybe that's a good argument that that's a bad definition of software architecture.
And
but to play devil's advocate, I think the stuff that's hard to change is not the kind of functions that a task is, but that there is a task type.
Oh, yeah,
Yeah, right, they're like the components that are described here is the stuff that's hard to change.
To rescue the hard to change stuff of it, what architecture does decides what about your project should be hard to change, what should be easy to change. Ideally, for example, if you go to the passes on a card, they make a few things that are easy to change, so you can go explore the state of the space of types of build systems relatively easily, and then you can move in that one easily. But it's hard to make a system that's buggy. Because if you start with something like make written in C, it's very easy to introduce a bug, but it's very hard to change a few things to turn it into shake.
Right.
And so basically architecture decides what should be hard to change and what should be easy to change. Maybe you can, if you want to rescue that sentence.
But there's a bit of a hindsight bias here, right? Because in this paper, they look at all these existing build systems and they tease out the commonalities and they tease out what is the parameterization that allows you to instantiate, to create each of them as instantiations. But when you're originally writing make, I think the architecture of it is exactly that you box yourself into that top left cell. And if you want to move from there, it is going to be a very hard change because all these assumptions, they're not made explicit the way in the paper they are made explicit, but they permeate.
But if you what you see there, have a few gaps in the table of elements in the periodic table. They predict new type systems that some.
Sure. I mean, you can come up with new bases. What I'm saying is that this is an outside and after the fact view.
There's a recency bias, is how I would say it, or something like this. Some kind of bias.
I really think it's just hindsight because.
Isn't that a good thing? Shouldn't we have hindsight?
No, I'm just saying that if you want to use this paper as a good source of definition for like software architecture, I would say that the architecture of any specific one of these build systems like make or XM, it does apply that the architecture is the thing that is very hard to change because if you wanted to change make to be like shake, to be phonetic, you
I see.
Breaking the tunnel.
So this suggests that there is a path to turn make into nix, but it doesn't mean that that's a path that you'll finish by the time you're done. Yes.
But okay, let's say for the sake of argument that we were to re-implement make. Okay, but this time with an awareness of that table, of that periodic table. We would implement it in a different way, right?
Yes.
Okay. So that we could like make small changes and turn it into whatever other build system we wanted. And it seems to me that what we are like architecture seems to me to capture the way that we would re-implement make. That is sort of the architectural difference between current make and this hypothetical make. And it's not so much it feels like there's something. I mean, we can make architectural decisions before we start implementing the thing, right? And so it's not only hindsight. It's right here. But
but here, we're not the fish, right? Like the fish doesn't know it lives in water, but we are not looking from the outside. But if you're writing your own stuff and you're not writing an N+1 implementation of make after having studied all these other build systems, but you're writing something that is like new or like unique, then you are the fish.
Yeah.
But you can of course go back and see what did we learn from writing make.
I'm wondering like how much of that is actually like dictated by the language or like the language that we decide to use, right? Because like
what is that?
So for example, like if we're using Haskell and we're using types and we're using the types to guide the implementation, then we're gonna have this very specific view of what's the high level. In the meantime, if you're using something, for example, object-oriented, that some things would inherently become easier, meanwhile other things will become much more difficult to change, and that's just by the choice of language. So kind of like the choice of API is partially dictated.
If you don't have higher kind of polymorphism, how do you even think about this?
If you wrote this in APL, everything would be a matrix.
But there's an interesting thing about that one. So if you look at say either file systems or say you look at version control systems,
Yeah.
If you basically write in something like C and you don't know what you're doing, you first end up with something like CVS, concurrent version system, and then like subversion. Stupid stuff like that. But even the C people eventually came up with something like Git. And Git is actually much closer if you look under the hood to something how you would write this kind of stuff in something like Haskell, because you have a graph and so on, the actual underlying concept. It just basically Haskell forces you to make decisions that that you only get after lots of painful experience when you write in C.
Yes, it constrains you towards a certain path.
And that's why I didn't pick C. Like I picked Haskell and I picked object-oriented because both of these are abstract, but they're abstract in different ways that make certain things easier.
Yeah. But I'm just saying that after you banked your head a long time with C or some object.
No, and that's why I picked two high-level languages. That's what I'm saying. I'm saying like these are two high-level languages that also make certain things easier or more difficult. One makes extending code sideways
but
harder.
it's eventually going there. Like for example, if you also look at copy on write file systems. If you know what that means. Even basically the people designing those file systems, they still write everything in C, like a really low-level language. Where copy and write is not really the usual thing. As copy and write is the copy and write plus garbage collection is the obvious thing that you do if you because
I'm saying
definitely.
The argument you're making is like you implement stuff in low level, but you need some sort of high level abstraction. I'm saying the high level abstraction partially depends on like how you think, and how you think is dictated by if you're a functional programmer or if you're something else.
We ended up with functions because you're using a functional language.
I mean, partially. Maybe one could argue this is a good interface, high level interface regardless, but like if you're an object-oriented person, then the high level interface will make it more difficult to add maybe what's called what do you say, object-oriented? Yeah, so it would make it more difficult to, for example, add like extend your types or something like that, change your types.
You're talking about the expression problem.
Yeah, like as in like, yeah, exactly. So to add more types of expressions, but it would make it easier to add instances or something.
Yes.
But I mean,
I think that's great.
Sorry?
I agree. I think that's a good one.
I think, yeah.
But you can use these tools of abstraction to think about the problem, even if you then, after you've done it on paper, you plan to put that aside and use your acquired understanding to then implement it in a non-functional system, right? Like to think about the design of the thing.
That's why I said that. Where was it? They used Haskell to study it. I guess I could have been more clear. But I wanted to say Haskell was a tool to study the concept and try to create the components, the abstract components that have to exist.
So if we sort of change the example a little bit and think about something like a server, a client server architecture.
Right.
So if just going by your two examples, like a functional language versus an object-oriented language. But like my instinct, if I were to do a client server application in a functional setting, would to use sort of extensive use of higher order functions to allow callbacks and stuff. But the thing is, that's not very different from that you do callbacks in an object-oriented setting as well. And I'm not sure that the choice of language is really the thing that would define which of the two architectural decisions that you would make in that.
I just want to use existential types and modules and whatnot in Haskell just to emulate.
Can emulate objects.
Yeah. So there's something else going on, it feels like.
But then
next year's functional architecture.
But then we're steering into the territory of you can program in Fortran in any language.
Yeah. You get to like the Turing target.
So I have an observation to make about make. So basically in the paper, I just looked at the paper that described make as having static dependencies.
Yeah.
Which if you see make sort of as the Platonic ideal, then yes, but the actual problem is that people take make, but then they tag on dynamic dependency in a really ad hoc and bad way. And they do that because basically they haven't really thought about the whole architecture and so on. If you have the hindsight of having this one, then you would see, okay, if you want to start dependencies, and instead of having like an applicative or something, we need to make our, for dynamic dependency, we need to have something like a monad. Yeah. And then you can think about it and then even see how do we do that in C, translate back, but they didn't have that. So that it's all ad hoc and weird and recursive make and even worse. So the problem is not so much like when you want to complain about Make or some other systems, basically the platonic ideal. But then once you want to do the extended, for example, you want to have dynamic dependencies in Make, then it gets really ugly if you don't have a proper understanding of the system. That's it.
Yeah, I think this is kind of a tangent from what you said, but I actually think Marcus's paper on the functional UI that we saw before lunch is an example of this, because he's trying to recast, at least if I understand you correctly, Marcus, I think you're on Zoom, redefine model view controller frameworks as functional combinator, which seems a lot, it's very similar, and is the kind of study that this paper did with builds, just for MVC and in UI. So I issue a challenge to everyone in this room, like maybe we can find more data points and then we can keep the workshop alive. Yeah. Is there any questions on Zoom or? No?
Oh, I can just.
When you say essential complexity, you mean the essential functional challenges, or complexity as in like time, space, sort of?
Not in time space.
Okay.
I
so
mean,
just give me
the essential complexity is defined in the paper out of the tar pit.
Right.
Yeah, which I don't remember.
Accidental
and essential complexity.
Yeah, so basically this essential complexity, accidental complexity, and the accidental. Yeah, okay,
So
that's the whole
like
thing.
I see. So the stuff that's by design.
It's part of the problem you're solving.
It's part of the problem.
Things are hard to change for a reason.
Yeah, like if you're going to parse something, you will have to read in chunks of data. You cannot avoid that. It's part of the problem.
Yeah.
Maybe that's fixed. Okay, well, that's great. I will restart the recording. Restart it. Great. Okay, the next one I had was future of FUNARCH. So this, I'm starting a tradition, and this tradition is to have a talk like this at the end of every functional architecture workshop. And last year, Michael Sperber had a talk on the future of FUNARCH, and so I figured I would follow him. And by follow him, I mean exactly follow his slides, slide for slide. So he started with thanking Perdita, and I wanted to start thanking Christine for being my co-chair. No.
It's almost everything.
Yes, but I didn't have the confidence to proceed, so you were back. So, and then this was the program committee for this year. I also should thank Michael Sperber, who also served as like a background advisor navigating ACM and SIG plan and hot CRP and all the stuff that goes into making this workshop. I don't think any of these people are in the room. Yep, but they served their purpose and they were friendly and, responded. So, yeah. So then these are the questions Michael had from last year, and I wanted to just ask the people in this room, because you're the people that showed up. And they were, is this worthwhile? Should we even keep doing it? Is it the right format? Last year they had this problem where they thought that the time relative to ICFP and other workshops was bad. That's why I think that's one of the reasons this was way at the beginning of ICFP this year. So those are the kind of questions in the air. The questions I had for this year are basically the same. So this is Pam. What do you think?
I mean, I came because the talks were interesting. Like I came to a few because, but I don't know if next year the talks are different.
Yeah.
In that sense, so it depends on the talks.
Well, I mean, this year we had, 3 presentations, right? It was a pretty substantial drop from previous years. And so I'm frankly concerned if we choose to do another year, that will be even less. So it'll just be me in the room yelling into the clouds about functional architecture or something. Or maybe with Michael. Yeah. Also. Any other thoughts?
I do think having it in Singapore has probably been part of the reason, because it's a bit far. It's a workshop and it's a bit far for a lot of people.
Yeah.
I mean, it's great for me.
It also seems like this. Like this is the first time I've I've been to FUNARCH, and it seems like it's quite sort of industry heavy more than sort of academic.
I'm happy you feel that way.
And then also, and then the Singapore aspect comes into it, right? That which companies can justify sending someone here, unless they are here already.
Yeah, I also suspected the Singapore aspect. But then I went and looked at the last time ICFP was in Asia, which is 2016, because the last time it was supposed to be was the COVID year.
It's in Japan though.
Yeah, it was in Japan though. Yeah, that's true. But the workshops I saw didn't have that much of a dip. But we're relatively new. This is the third official year. Before this, there was hallway FUNARCH workshops where we would just complain about stuff. So. I'm not sure we want to continue to be co-located with ICFP.
Well, it's probably even harder to get people just to move, because if you're going to ICFP anyway, then dropping, like it's easy to walk over. So.
Yeah, I mean, I do, like Michael would say that there's lots of cross-pollination that can be had, and I agree with that, but I find that I think we're having a hard time marketing that. Also, like I was saying at lunch that, if I have an architecture thing for something at work and I wrote that in Erlang, well, I can just go to Erlang and present it there. Like I don't have to present it here, right? Same thing with Haskell, Scheme, you can run, although I don't know who uses that. So, yeah. I was thinking maybe it would be better to put this workshop somewhere like in Zurich, which is already more kind of less academic and closer to industry, I would say.
And
and cheap. And cheap, yeah.
Zurich is more expensive. Well,
oh, it's maybe it's overly Haskell focused to put it at Zurich. Zurich's the largest Haskell gathering in the US and Europe now, I believe. It's a free ETH, and it's a free conference. It usually attracts a lot of Haskell people and Agda people.
Right.
But yeah, I guess I wouldn't force this workshop to be more Haskell focused.
Yeah, I think it would be interesting if FUNARCH was made more targeted towards industrial, potentially even re-architecture of functional stuff. So you have an existing functional program, you analyze the existing underlying architecture and design a path where you want to go, and then show issues you got getting there. I guess it's closer to like functional pros, but more on the industry like architecture side of thing. I think that would be interesting if it would be pushed that way.
Architectural pro.
Yeah.
Maybe the network also it's a bit bigger than we know who's then people already know they're going. People who already know they're going to the conference or maybe other workshops could submit once they know that they're going anyway or something like that. Because especially or like just also introducing like extended abstract like
I was in that too.
Extended abstract so that it's a lower
barrier to entry.
Yeah, like just give a talk about what they do without having to write and
Yeah, I agree. I think that there should be an extended abstract and then just a presentation. Because I think that it's a large burden to write a paper if you're in industry. You have to shape features.
So the question I was asking is because the stuff we do at work, I'm not sure they would fit into the current FUNARCH part or not.
Well, when I worked in that team, we published a paper.
Right.
Back in the day.
But
it was a good paper to read it.
But would the stuff we do on Cabal be FUNARCH parts? So
mine's the fun.
Sorry.
Well,
you can do the presentation next year, just strike out the fun.
I think that's actually a very good experience report. Because there's
but then it's an experience report. Is it FUNARCH? Is it functional kernel?
FUNARCH accepts experience reports.
Yeah, but then we should probably like be more aggressive in marketing in that direction. You actually work on large scale functional code bases and you have made changes to the architecture or whatnot, and here's your venue to present about
Right, yeah. Yeah, I think that's good feedback, yeah. I also think that we hopefully get more people showing up.
And what you could also do, I'm not sure if it's useful, but instead or in addition to talks, you can also have posters that people can just look at the hallways. Like
Yeah.
sometimes that's for students, but if you're in the industry, you could also just.
I think posters are more of a student thing.
Oh yeah, but I mean, why not? And just make, because in industry, if you don't want to don't run a whole paper, make a poster, and then people can talk to you about it in the hallway.
Yeah.
Maybe, I don't know.
I'm not a fan of the posters, but that's just me personally. I mean, I don't have to.
Have a session with the end, like just like the panel session, so like a poster session, so it doesn't have to be super like heavy on the organizing side, but just.
Yeah, like the last session of the workshop. Sure.
Like that.
I guess that's okay. I'm coming around.
Yeah, no. So my motivation was that you don't need to compete this ICFP or whatever for people, because you can just people on the hardware anyway. They can have a look at the
I also think it might be a good avenue for students.
Maybe if the students will have.
Well, I'm thinking of like a lot of PhD students are very motivated to contribute to like the OCaml compilers.
Yeah.
And they probably have something to say about confusion and what they, how they did it and stuff.
Maybe.
I don't know if this is the right venue, but perhaps.
Like a student session, it could be like a student track and have a session for
Yeah,
students.
yeah. And I think that also intersects nicely with some of the work Michael does. So student session, or very
As a student, don't usually work on like nicely circumscribed
Yeah.
problems, so you don't really interact with the parts that benefit most from a good architecture.
It's not in the large.
Yeah.
Yeah.
Well, unless you're working on like one of the compilers or something, also particularly.
Zidane, who was here earlier, was working on an enormous, like compiler for language that we use for verifying file systems. And the first couple of years, we didn't publish anything because we were in academia, and it was just like hacking on a compiler. So it could have been a good venue.
Yeah, prompt could just be, what's the stuff that's hard to change.
But you give it 12 characters. That's architecture, what you do.
We should talk about, okay, this ages.
I'm not sure if you're allowed to, but.
Maybe you can talk about how you reorganized the file. That was ages ago, but that was basically.
I guess the nice architectural thought would be if we ever get to changing GHC so that we don't need to customize it that much. I don't know how we need to do that to virtualize parts of it, but that's not work that has been done already, so it's hard to think about it.
Well, it's architecture, it's not necessarily done work, right?
That's true, yeah.
It could go like, if we had this architecture, this would be much better, this is where we currently are.
Have a whole workshop of ideas for things that are hard to change, but nobody has the time for.
Oh,
That's the workshop, building the will to have time.
I mean, you could try sort of to do negative stuff, like as opposed to over here, we do an experience report, and this is what really works.
Yeah, the experience report of working on Wall.
Yeah, look at Kabal.
The night was dark and I was full of despair. Yeah. Extended.
For example, is the first workshop, the security workshop with conjugated Popple. So that started off as a meeting for people who are interested in secure compilation, and it started off as a like, before we start actually implementing stuff, let's discuss it and see what makes sense and what doesn't. So I think that just having a bit of it be like also stuff that's not done and just experience reporting, but rather let's discuss if certain architectures or certain things would be a good idea or not would be nice. And also whether it's for students or people in industry, I don't know how much people in industry are allowed to talk about what they do, but like the aspect of getting some people who do similar stuff to discuss it before doing it. So things like the initial idea of a workshop.
Yeah.
Work that's not done, but work that
Yeah.
getting feedback from the community on stuff you're still up to.
Yeah, as someone who works in industry, I don't know what I'm allowed to say, only legal does, and then they just tell me. But I think that's great, yeah, feedback for work in progress.
All our sessions should be in a dark room and everybody has an eye mask.
Yeah.
So nobody can trace it back to.
Right. Okay. I appreciate your feedback, and I think this concludes FUNARCH 2025. Hopefully I'll see you next year.
Thanks, Jeff. For
Yes, next year.
Thank you, Jeff.
Thanks for being co-chair.
Where's next year? Where's ICFP next year?
I think it's somewhere in the US.
Don't usually announce it at the end of ICFP.
Yeah, it hasn't been announced yet. But,
Yeah.
Okay.
But it was Italy, and then now it's Singapore. It's better.
North America anyway.
I'll check the prediction markets.
Yeah, I'm kind of hoping for like Toronto. That'd be great. Yeah. I also hope I only live like 2 hours from Toronto by car. It's like it's cheap.
Where are you located?
In Buffalo, New York.
How is it Ottawa? So any excuse to get to Canada is great.
Oh, yeah.
See you on the website. Using the ICF people.
Oh, you're
Yeah, like I'm here to.
Thanks, Marcus.
All
And
in
I'm
this part,
hoping that
but
the recordings I know you get,
Bigger from Europe.
especially the state has to stop good alive, and they have a good reason.
That was cheap.
So I'm Facebook member, I'm working on a static, but I have some, I have started looking for work, so
Oh, yeah.
so I,
It was,
in the last 7 years,
uh,
I've been working in the
Like I left Thursday at 3 AM and I arrived Friday at 9
doing
PM.
compiles for smart contracting.
But I think that Singapore is a great school.
So
It's just
initially
hard
Silica
to
before
convince
they
people, yeah.
before they ran out of money.
hold on.
And then Polygon for a while, and then yeah, the last one was Fuel Labs.
Okay, I actually don't know much about this. Were you using last one?
No, we used Camel in at Silica, and then the rest of it is.
Yeah, I tried.
Which is the
You're talking about the one I did?
the way I
I tried it.
it is C++ done right,
I'm like,
and Camel done wrong.
no, it's not a. You're
Oh, the tracing,
Yeah.
you mean, or did it work?
It's like, well,
At least you're.
the point of this is that it's the way that references, the way they handle references is smart compared to what C++ does.
Yeah.
But the only reason they have to do it that way is because they insist on keeping track of mutability.
Yeah.
And yeah, sure, but then, just do a camel and then problem solved.
But the camel, you don't have destructive, you need a garbage collector, I mean, that's the problem, right?
Yeah.
Like,
Sure.
it's so.
You need a garbage collector in Rust as well. So.
There's no garbage collector now.
No. Not use Rust.
Yeah, that's one of the reasons to use it, yeah.
Like that, so.
You can strip it all the way down to not require locators.
Also,
Don't work with people who obsess over, okay,
Yeah, okay.
a bit more time, then, yeah.
Yeah.
Then it's great, but.
yeah, also the Rust compiler makes extensive use of hand-rolled arenas, memory arenas.
Yeah,
They allow their own.
Regions or what's the arena?
It's, you take over, you have a component, like say your parser or your
Yeah.
optimizer or something. And you say, I am going to use like 3 gigs of data, and you allocate it all in the beginning.
I call it the buffer, yeah.
Yeah.
Oh,
So
they
they-
do it all at
Like,
once.
Exactly, so you allocate memory, you do stuff dynamically
Yeah.
within it and then.
An arena is just a certain kind of pattern of buffers like that.
Yeah.
Okay, so.
And the point is that you usually allocate everything together, so you don't have to track dependencies because everything burns off.
Yeah, like, this is interesting, I should check what an arena is.
Oh, yeah, there's lots of stuff.
There's
like
just like tag, load, maybe a
there's
couple of
very,
things in the middle and.
yeah, there's an entire like spectrum of different allocators like this. And arena is just one, like another one's like a bump allocator. And
A bump.
yeah, you allocate an object and then you just bump a pointer. So you're like recreating